a must attend for whoever is interested in the trajectory of evolution of SAE standards and amazing and remarkable success that it has achieved in the mobility community across the world, across 45 nations. Having gone through the introduction to SAE standards, need for them, NADCAP, HM1, G31, G32, G34, E40, G19, A6, G35. Hold on, wait. If these numbers rattle you, I'll make it simple if you're attending for the first time on the second day. National Aerospace and Defense Contractors Accreditation Program, that is NADCAP. Integrated Vehicle Health Management HM1, Electronics Transaction for Aerospace G31, Cyber Physical Systems Security G32, Artificial Intelligence in Aviation G34, Electrified Propulsion E40, Counterfeit Electronics G19, Aerospace Actuation, Control and Fluid Power Systems A6, Modeling, Simulation and Training G35. This is what you have seen yesterday on two tracks, that is the parallel track 2 and the main track, which is track 1. So members, we shall now move on to the interesting and last day of the SAE India's Aero Standards Workshop 2021. We shall start with SAE ITC. SAE ITC is SAE Industry Technologies Consortia, which is an affiliate of SAE International, and its membership is comprised of public and private organizations collaborating in a neutral forum to drive innovative solutions to key industry challenges. And now about the first speaker of the day. Mike McNamara is currently serving as the Vice President for Aerospace with SAE Industries Technology Consortia. The aerospace portfolio, in combination with other SAE ITC programs, provide coverage across both manned and unmanned aviation, supply chain, parts qualification, digitalization, advanced manufacturing, and space. Mike's background includes all product lifecycle phases. He has previously led autonomy, AI, and human-machine collaboration efforts at Bell, which was earlier known as Textron, robotics, unmanned systems, and advanced manufacturing at the University of Texas, the Arlington Research Institute, and air and ground unmanned systems architecture and software as part of the US Army Future Combat System program while at SAIC. We are indeed very happy to have the speaker from SAE ITC, and the floor is yours. Mike McNamara, over to you.
Very good, and thank you very much. I appreciate this opportunity. Thank you for your kindness. I'll go on ahead and start sharing, and we'll begin this journey of being able to let you know what SAE ITC is all about. Let me do a quick check. Are you able to see my slides at this point?
Yes, we can.
Yes.
All right. So again, thank you very much. It is my pleasure to be able to join you today and to be able to share with you some information about SAE Industry Technologies Consortia. As a little bit of background, SAE is actually composed of 3 primary affiliate companies. You're very well aware of SAE International with the involvement here. We also have, as a part of the group of companies and affiliates associated with SAE, we have the Performance Review Institute. And yesterday you received some information about NADCAP and some of the programs that are a part of PRI. Today I'm going to be talking about SAE ITC, or Industry Technologies Consortia. The company itself was founded in 2003, so it is the youngest of the three affiliates. And just as with SAE International, we focus on technical standards and best practices. We also focus on bringing organizations together. And that is a key distinction in how we do business. So looking at this from a different point of view, with SAE ITC, we bring organizations together. SAE International brings individuals, experts in their fields together. But there are moments where within an industry, it is important to bring organizations together so that they can collaborate with one another and solve problems and address issues that exist at an industry level. And in doing so, we've put together forums or consortia to make that happen and to facilitate that communication and that cooperation. With SAE ITC,
Mike, your voice is a little low. Can you speak up a little bit?
yes, thank you.
Thank you.
Yes, with SAE ITC, we are, in a way, it's best to think of SAE ITC as an umbrella or an encompassing company that includes roughly 15 smaller companies. Each of these represents one of these consortia. SAE ITC is broken up into three different sectors. We have the aerospace sector, land-based sector, and multi-sector. And I'll be covering some details with each one of these as I move forward. SAE ITC and its constituent programs has been around for quite some time. The oldest program is ASPQP, Aerospace Parts Qualification, that has been around for almost 100 years at this point. Next is ARINC. For many of you who are involved in commercial aviation and commercial aviation standards, you're very well aware of ARINC standards. And the list goes on, and you can see the timeline here in front of you. One of our most recent endeavors is Octon-X, which is based in the Netherlands, and we'll be addressing some unique opportunities in the European area. For SAE ITC, our strategic framework is really quite simple. It's focused on the industry, regardless of what that industry looks like. We focus on what we call our 4 C's: contacts, capabilities, content, and context. If you put these together, it's important to realize that in order to solve problems and to collaborate, you need to have contacts. There needs to be a network for which people can come together. Those people then bring their own capabilities to bear on industry issues. And those capabilities are backed up by content. The capabilities and the content that are brought by our consortium members all operate within a context of addressing an industry level issue. As a result, by bringing them together, we're able to form great communities and be able to put forward great industries. SAE ITC provides the legal structure, the governance model, and has a historical performance of success that allows new consortia to come online and to address new problems that come along. SAE ITC, while the newest member to the SAE group, actually has a number of successes. And some of the numbers that you see here help show that. In terms of US dollars, we have over $700 million in funding from the US government, $10 million in revenue. We've issued over 32,000 personnel credentials through Probitas authentication. We supply our own blockchain database with over 10,000 records, and so on. These numbers represent the extent and the success of SAE ITC. We also bring to bear a wide range of expertise that covers the entire integrated product lifecycle. And really what we're focused on is empowering organizations to increase their systems, processes, and data management, assist with standardization and best practice capture, improving participation across all sectors, whether it's industry, government, or academia, help with registrations, qualifications, and certifications by providing services to do so. And then almost most importantly is providing pre-competitive communication and collaboration among the members. In short, it's a visionary collaboration that we use to advance technology. We truly believe that working together is more effective than working individually. And in that way, we're able to achieve a mutual benefit, solve common problems, and therefore increase business value back to our members. This is a glimpse at our process for forming consortia. It is really a collaborative journey, as the title of the slide indicates. We start off with someone having an idea. There's a recognition of a need to solve a problem within industry. Once that need is identified, we get involved and we begin to form forums that allow for exploratory conversations. Out of those conversations, the idea is to identify a champion, an industry leader who is going to help this new consortium, as it's being formed, to move forward and to help provide that leadership role. Once we're assured of sufficient interest across the industry, then we'll begin to formalize the process, start holding discussion groups, and start putting together a target proposal where we'll identify the scope and some of the founding documents that will go into a future consortium. Because this is meant to provide value back to the members, we will also spend time putting together that return on investment and value equation. We'll understand what the benefits are, as well as the risks. And once those foundations are in place, then we're ready to put together a group agreement. And it's that group agreement that actually then starts the consortium and allows it to move forward. So anywhere along this path, it's entirely possible that we get to the end and we have started actually a new project under an existing consortium. It may be that there's sufficient overlap with an existing effort that it doesn't make sense to start a new consortium, but we need to expand the role or the scope of something that already exists. Second, it's possible to start a new consortium. Third, it may be that more research is needed, maybe more market research, a larger assessment of what's going on in industry. So we'll start an exploratory project. And then it may be that we get to the end and realize it's a great idea, but the industry just isn't ready for it. And so we'll wait and find the right time for it. With looking across an entire integrated product lifecycle, SAE ITC is able to bring together expertise that may not exist in other ways. Taking a more holistic and top-down view is critical and important in order to establish context for any of the consortia that are formed. So let's look at this from a different perspective. How do you, in an industry sector, move forward with standards development organizations and with consortia? Let's take a look at that. In a sense, this is a path that we're going to explore. So we'll start in the center. Being in the middle of this with industry, academia, and government, you are the practitioners. You're putting together products, services, generating data. You have a job to do and a return on your investment to account for. So there is a practice that you're involved with. By bringing multiple organizations together, now we can begin to leverage the lessons learned and be able to capture best practices and standards across these practitioners. And in doing so, we can identify registries for qualifications and certifications, identify the need for tools, and so on. So this becomes a level of support that's outside of any one organization that now SAE ITC can help provide. There's a third level, and that's within a framework, and that's the organization itself. That's SAE ITC within its current role. So we are able to provide the legal framework, the administrative framework, the organizational framework for capturing these best practices and generating new standards, and working with the stakeholders so that we now have feedback back into the process. And all this is done to help facilitate neutral collaboration. That way, it's not just an organization that's doing this, a for-profit organization or an academic interest or a government agency. Now it is a third party, the consortium, that's actually moving forward and facilitating this work. The next few slides will give some additional detail on each of our programs. My intent really is not to read through these slides, but instead to have these available and for you to take a look at. This slide is looking at our three aerospace programs, AESQ, or Aerospace Engine Supplier Quality, brings together top executives from the aerospace industry. These executives and their respective companies bring together the key manufacturers of aircraft engines. This is where the standards are brought together for those engines, and this is where those decisions are made. AIRINC, well known for decades, is composed of three committees: Airlines Electronic Engineering Committee, Aviation Maintenance Committee, and Flight Simulator Engineering and Maintenance Committee. Within AIRINC, most of the commercial aviation needs are addressed in one standard or another. ASPQP is Aerospace Standards Parts Qualification Program, which is literally the standards and qualifications activity for the nuts and bolts and connectors that hold together aircraft. This is what, in a humorous sense, this is what holds the industry together. We'll take a look at a different view of this. When you look at different areas of aerospace, whether it's on board and controls and navigation, within the cockpit, the cabin, engines, whether you're looking on the ground and training with simulation and training, communications to bind it all together, operational support, or integration with data through communications. SAE ITC's programs cover this entire range. It's more than just the vehicle, but it's trying to address the ecosystem as a whole. We also have programs with our land-based area. We have our Automated Vehicle Safety Consortium, International Alliance for Mobility Testing and Standardization, Mobility Data Collaborative, and the Vehicle Identification Number for Off-Road Vehicles program. Each of these address ground-based vehicles, but because of commonality in technology and tools, what we see is a collaborative effort between aerospace and land-based programs. And we see the effort between the two being very profitable and very useful. You can see in a similar diagram the span of these land-based programs and how they stretch across different areas of ground transportation. Finally, we'll look at some of the multi-sector programs with DATSI Defense Automotive Technologies Consortium, ExchangeWell, which is focused on digital data marketplace, digital data management. This includes blockchain and artificial intelligence. HRCS, which is looking at smart and intelligent electronic components, more than just diagnostics and prognostics, but moving into self-diagnosing subsystems as well. IBIS, which is looking at an analog level of interface with integrated circuits. Probitas authentication, looking at credentialing services across the aerospace industry. And SAE AMS AMDC, which is a consortium looking at additive manufacturing and developing spec minimums and spec standards for additive materials. So as we begin to wrap up this overview, I'd like to emphasize these 5 key areas for SAE ITC. What motivates us? What wants us to help? How do we want to help you? And we would like to do that by accelerating your data products. We believe that having a diverse membership is imperative and critical to our success and to yours. We're always on the lookout for additional services to provide, and we are very global in our leadership and our partnerships. We believe in moving fast and decisively, just like you do in your industry endeavors. So in closing then, we look for common engineering solutions, and by working together, that we remove barriers to innovation. So SAE ITC, through its consortia efforts, are doing that in aerospace, ground transportation, and across various technology areas. So with that, I believe I'm just about on time. Here's my contact information. If you have any questions or desire any additional information, I'd be more than happy to speak with you. Feel free to reach out to me via email. And let's not end the dialogue here, but let's feel free to continue it. And thank you very much. And over to you. Thank you.
Thank you, Mike. I think that was a superb presentation. I am Venkat, Deputy Director General for SAE India. So I'm very excited to know about the subsystems and components, constituents of SAE ITC. If Mr. Coronavirus allows us, we invite you to come to India. I think we can make a program. I'm sure our aerospace chair and Dr. Ravi Kumar and others will agree. Thank you so much.
And thank you.
Are we taking questions, Dr. Ravi Kumar and Ravi Shankar Mysore?
Yes, we can. If it's,
Any questions in the chat box, the SAE team? So far, so good. No questions.
yeah. I think we can move on to the next session with more questions.
Okay. Thank you, Mike. That was exhilarating. Thank you so much for joining.
Thank you.
The inventor of the lithium-ion battery, you know who it is? John B. Goodenough has developed a safer and more efficient battery. So, ladies and gentlemen, what is in a name? That wasn't good enough, right? And we are moving beyond lithium-ion battery. The next speaker doesn't need introduction. It's all in the name, Dr. Ravirajan. One of the key objectives of setting up any standards is to improve efficiencies. The role of standards is to improve efficiencies and quality. Dr. Ravirajan, who is no stranger to SAE Indians, will take you through the journey of improving efficiencies and quality. Dr. Ravi is an independent consultant and research professor at University of Connecticut, working on applying model-based and data analytics techniques to aerospace and other complex systems, especially in the areas of controls, diagnostics, and prognostics. He has 6 books to his credit, including Electric Flight Technology, The Unfolding of a New Future. In addition to these books, Dr. Ravi is the author of many book chapters, journal papers, conference proceedings, and more. He is named inventor on several patents. Thank you, Dr. Ravirajan, for joining in. Over to you, sir. The floor is yours.
Thank you, Venki. That was very nice introduction, and thanks for the invitation. Now let's see, how do I get this to work? Let me know when you can see my screen.
We are staying on. Yes, we can see
Okay.
your slide. Kindly put it in the slideshow if you don't mind.
That's a tough one. Okay, let's see.
Okay, over to you, sir.
What are you seeing? Are you seeing the presentation or are you seeing my?
Uh, I am seeing aerospace standards for efficiency and quality.
I
The
know
blue
that, but
color.
is it the speaker view or the presentation view?
A full view,
Okay,
presentation
good.
view. Yeah.
So I don't have to mess with it.
Yes.
All right. So this has always been a problem for me. I'm glad I figured it out this time. All right. So I'm going to talk about, actually, the topic was efficiency and quality, which is what Ravi Kumar asked me to talk about. I think one part of it is sustainment. That's what I'm going to concentrate on because that's really what I'm interested in. And hopefully that is something that I'll make you guys interested in as well. And hopefully some of you can join us in this journey. Okay, so efficiency and I'm going to say environmental quality is the big deal these days. These are some of the big programs in the air today. I'm sure all of you know that Pipistrel got its certification, which is the first time that an electric aircraft has got a certification, which is great, but many more are coming. There's also hydrogen going on. And the conventional OEMs are not falling behind. They are also increasing efficiency with their gear turbofan or these open rotor concepts and the ultrafan. So the world is moving on. Yes, the future might be electric, but it might be other things as well. SAE, as you all know, and Mike did a fantastic job talking to you about ITC, but SAE obviously, and yesterday you found all kinds of information about all the new stuff SAE is doing. So between SAE and Airing, the organization produces several thousand aerospace standards. It's like, and I think David gave you a good idea of what the total number of standards, etc. is. So I won't go into that. In terms of design and certification, which is really the key to having a good quality product, the systems development, safety, component processes, and management systems group, which has S18, G19, G22, etc., G14. These are this is sort of the group which actually deals with the basics design and certification and quality within aerospace project. So the quality standards come under this systems group. The counterfeit parts and materials, which is what you heard about yesterday, also is under this. So this is probably one of the best systems groups to associate yourself with if you're interested in the area of design and certification. As part of this is one of the most important groups within SAE, which is the S18, which produces 4754 and 4761 and many other related documents. This is something I know a lot of you are very familiar with. And in terms of the systems engineering process that brings about a product, an aerospace product to fruition, these are the tools that are needed within it. And as you can see, safety is a big deal in this. As part of the design process. But it doesn't end there. Certification has several aspects to it. There is the product, as you can see, which is the airframe, the engines, the propellers, and all the subsystems associated with this. There's also the process, which is the manufacturing, the software development, as you guys are very familiar with, DO 178 and 254, etc. The airspace as well, air traffic management, and all that has to be certified as part of the safe aerospace environment that we live in. But there's also the idea of certifying people for flying, for maintaining, etc., and also the companies, because the processes associated with the manufacturing depend on the companies that actually run it. So they have to be certified as well. So there's a huge ecosystem that goes along with this whole certification process. But it's not just design and certification. One of the major things within in this ecosystem is how to establish rules for maintaining these aircraft as they age. That is where instructions for continued airworthiness come in. This is the way the regulators develop rules or actually work with the industry to develop rules to ensure that the aircraft can be maintained along its over its life cycle. It includes airworthiness directives, engineering changes, bulletins, etc., as a lot of you are very well aware of. But two of the main items are the instructions for airworthiness, which is a documentation that gives instructions for how to maintain, and also the limitation section, which is part of this, where you have to be very, very cognizant of when things run their course, what is the usable life of a part, etc. So this is a key part of the aviation sector, which sometimes gets ignored. I wouldn't say ignored, but it's not as sexy as a topic as the design and the certification part of it. However, we in the health management community are very much in this part, and the IVHM, the Integrated Vehicle Health community, is involved with the regulators and with groups such as the MPIG, which actually develops guidelines for maintenance in the aerospace area to develop all these standards. So I will highlight a few of these within the IVHM steering group. Rhonda Waltall talked to you about the IVHM steering group yesterday. For those of you who attended, I am now the chairman of this group. And within this steering group, we have the E32, which is the Propulsion Health Management System, Health Management Technical Committee, the AISC SHM, which is the the Technical Committee for Structural Health, the HM1, which is the IVHM Technical Committee, and the G11, probabilistic methods and maintainability. They're actually changing the name a little, but it hasn't been finalized yet. So some of the key documents that have been published in this area of continued airworthiness and the use of health management functionality and systems within this ecosystem are ARP 5987, which is how to get maintenance credits, and it is now being worked on and being updated. ARP 6461, which is how to implement SHM on fixed wing aircraft. They are now coming out with a rotor wing version of this as well. JA 6268, which is Mike McNair talked about the health ready components and systems consortium. That thing started with this document, the JA 6268 document on health ready components. And then we also have a bunch of maintenance related documents. Some of you may have read this. RCM processes is the keystone for developing the maintenance programs for aircraft, and JA 1011 and 1012 are the key to that, describe that. And we are actually within HM1, we are working on a JA 10, actually that should be 12, I believe. No, 1013, I'm sorry, on condition-based maintenance recommend practices. So together, I think there will be a whole bunch of great documents that help in the sustainment area. I'll give you one example of a document that and what it covers. And ARP 5987, which was published in 2018. It took 10 years to work on this and publish it. We started it in, I remember, East Hartford in 2008, and it was only published 2 years ago. 2.5 years ago. It has inputs from major OEMs, but also importantly regulators. And it will be, I won't say superseded, but at least it'll become the basis for a vehicle level health management for maintenance credits document called 7122, which I'm working on now. Again, I mention all this because if anybody is interested in this, these are going to be important documents. Please join us and work with us on this. And the whole idea is that we emphasize the end-to-end nature of HM. So 4754, 4761, these DO-178, these are all for airborne systems. We realize in the health management world that we are end-to-end, all the way from the aircraft all the way down to ground systems. And Ravi Kumar talked to you about G31, and Mark talked to you yesterday about G34. These are actually committees that have been stood up recently because we realize that data is a universal entity. It goes from, it's not just on board. Used to be a days when you could do everything on board, but no longer. All that data has to come down. You have to have ground-based system. You have to have interoperability between these. So that is extremely key to the entire health management ecosystem going forward. And SAE has realized that, and it has stood up all these new committees. And Andreas yesterday talked to you about G35, which is the modeling, simulation, and training part of it, which is another key element of this. Let me give you an example of what I mean by a maintenance credit. Okay, let's take an example of a oil debris, let's take oil monitoring. Typically, you have what are known as mag plugs or magnetic chip detectors. You have to inspect the engine oil by actually pulling these out and looking at it for metal filings every, let's say, X flight hours. Could be 100 engine flight hours or whatever. This indicate any impending mechanical failure within the oil circuit. So such as in bearings and gearboxes. With the gear turbofan, this becomes very, very key, critical safety feature. So typically what you do is you pull these mag plugs and look at them. Now, suppose you put in a health management product within there, a function there, which is the inline oil debris monitoring system, which is a continuous oil debris monitoring system. What's happening is it is looking for these debris as the oil goes through the circuit, which means that you don't need to inspect these every X hours. Maybe you can make it every 3X. So instead of 100 hours, you can go 300, 500, what have you. Because you know that between these inspections, you have an online monitor that is sensing any debris that is going through. So what happens? Because of this, instead of every 100 hours, you're doing it every, let's say, 300 hours, or every X, you're doing it every 3X hours, you get a maintenance credit, essentially, of 200 hours or 2X flight hours. So that is essentially the reason why we call this, why we say that health management systems can get you maintenance credit. So that's an example. There are many others, such as with the usage-based lifing, etc., which is part of the limitations chapter for continued airworthiness. But you get the picture, right? I mean, this is an extremely important function because it allows you to lower the cost. So let me summarize what I've just said. SAE is working on developing documents, not just for design and certification, but also for sustenance. And one of the ways we can do that efficiently and with quality is by using health monitoring systems. And we within the IVHM community are key to developing those systems. And we have several technical committees within the IVHM steering group that are helping develop this. This is going to be a big focus for the steering group and for the constituent technical committees. So I do request anybody who's interested in this field to join us, because I think this is very important. It lowers costs, but increasingly it also enhances safety, which is the key to sustenance. With that, I thank you. Are there any questions?
Any questions in the chat box, members, SAE team? So far, we have not received anything, Dr. Ravi.
That's perfectly all right.
I have one question.
Yeah, please, Ravi.
Okay.
This is regarding the maintenance credits that you mentioned, right?
Mhm.
In terms of the cost savings. Okay. So, do we have the necessary approvals from the FAA and EASA as of today, or it is in the process?
So, very good question. And I know you know this, but for the rest of the audience, that is one of the biggest initiatives that we are taking within the steering group, IBHM steering group. We have an initiative to work with the with the authorities as well as the MPIG to develop processes whereby health management systems can be approved. So let me give you a couple of documents that have the regulators are working on. One is Advisory Circular 43-218, which is on guidance for how to certify health management systems. So it has not been published yet, but it has got all the feedback from the industry. It is going to be published anytime soon. We are working with this with that group. The other group we are working with is something headed by the FAA. It is called the IMRBPB. It is the International Maintenance Review Board Policy Board. 10 major regulators. I'm really surprised that India is not part of this, considering that it is the second biggest aviation market, well, third biggest today. I think that DGCA should be part of this. I'm going to see how we can change that one of these days. But they come together and figure out how to regularize maintenance rules across the world. And they work closely with MPIG. So what we are trying to do is influence that group. And the document that they publish, well, MPIG publishes is MSG, and it's on it is the maintenance steering group number 3. It is now it's going to be revision 2022. Next year they're going to come up with another one. I don't know what's going to go in it related to this. Certainly the health management, structural health management will be a part of it. But we, in the next revision, hope to get a lot more of IBHM content in there. So good question. And it is actually really, if you guys are interested in this, I know for some it's exciting, for some it's boring as hell. But if you are interested, if you're excited by this, please join us, because we do need the help.
Thank you, Ravi. It was a wonderful answer. So there is one more question from Venkatesh Ashok.
Yeah.
His question is, what is the criteria to determine the maintenance credit?
Well, it's different for everything. I gave you one example, right? Where you have a way of lengthening the time interval between inspections. So for every 3 inspections that you were doing before, you're only doing 2. Now, pulling a mag plug chip detector may not be that expensive, but it is still time consuming and expensive. So at least you save that much of maintenance. There are other examples where you can save millions of dollars, especially related to rotors, related to landing gears. These are expensive items, and you can save a lot of money. So that's one way of looking at maintenance credits. Vibrations. how to actually monitor vibrations and make intelligent decisions based on that is another way. There are many other gas path analysis, etc. So there are a number of examples of how health management systems can be used to obtain maintenance credit. This is just one example.
I think we have few more questions. Venki, do we have time or shall we take it offline?
Sir, I think we should take it offline.
Perfect. Perfect. Thank you.
No problem. Hey, thanks for listening to me.
Thank you, Dr. Ravi.
Thank you.
Feel free to send me an email. You can reach out to Ravi Kumar or whoever to get my email address, and I'd be more than happy to talk to you.
Thank you so much, sir. So, ladies and gentlemen, after having listened to SAE ITC and the IHIM story, now it is a time to move on to the UAS. You can be seated wherever you are, but we're going to send the unmanned aircraft systems to Dr. Mark P. D'Angelo. The scope of unmanned aircraft systems and autonomy is enormous, encompassing small drones, large UAVs, fixed wing, traditional rotorcraft, eVTOL aircraft, conventional power plant configuration, and distributed electric propulsion, DEP. Don't tell anybody. SA India has just completed the first ever urban air mobility virtual symposium last week. And guess who is the chief guest? The chief guest was Honorable Minister for Civil Aviation, Shri Jyotir Aditya Scindia. And second day, the chief guest was Joint Secretary of Ministry of Civil Aviation, Mr. Amber Dubey. So now over to the speaker introduction. Dr. Mark is an aerospace engineer and aerospace initiatives manager for SAE International with over 13 years of experience. He is the SAE spokesperson for Advanced Air Mobility, AAM standards, that is AAM standards and integration activities, collaborating with SAE, NASA, FAA, ICAO, International Civil Aviation Authorities, and industry. Dr. Mark co-chairs the Airworthiness Group, that is WG1, and co-authors the ANSI UAS Standards Collaborative Roadmap to support rapid development of needed standards to facilitate the safer and faster integration of UAS into National Airspace System, NAS. He actively supports the G34 Artificial Intelligence in Aviation Outreach Committee and its podcast. Dr. Mark earned a BS, MS, and doctoral degree in aerospace engineering from Penn State University. He also holds an FAA Part 61 private pilot certificate. The floor is yours, Dr. Mark, on UAS. Over to you, sir.
All right, thank you for that wonderful introduction, and also thank you for this opportunity to speak with all of you today. I want to say good morning, good afternoon, and good evening to everyone. This is wonderful to be able to speak with everyone around the world today. So I'm going to share an overview of SAE International's UAS activities. So hopefully my screen is visible to all of you right now. I am sharing it. So
Yes,
I'm going.
Mark. It is
Okay,
visible.
fantastic. Thank you. So on the agenda today, that's my slide. We have an overview of SAE International UAS standards. That's going to cover the SAE Standards Developing Committees, and more specifically, some of the SAE standards that those committees develop. And those standards include both published standards and works in progress. I'll probably focus a little bit more on the works in progress because that's what's happening now. All of this information is available for you, especially any of the published works and works in progress. That information is available on our SAE mobile list and our SAE standards works pages. And then I will then give a brief overview of where these standards support the ANSI UAS standardization roadmap. And Ritesh Jamira will be speaking about this ANSI UAS standardization roadmap version 2 in more depth and detail. But I'm just going to provide just a quick overview and show where these standards relate to that roadmap as a primer for his presentation coming up. And you'll have a better understanding about that roadmap in the next presentation. So SAE International participates on several UAS industry activities. For example, as this is stated, there's the standards committees that develop standards for UAS. SAE also contributes to the ANSI UAS Standards Collaborative Roadmap. I'm the co-chair and co-author of the WG1 airworthiness. SAE is also one of the key standards developing organization partners, providing guidance material and acceptable means of compliance to ICAO provisions. We also provide standards as means of compliance to the regulatory authorities all over the world. Those regulatory authorities, whether they be FAA, ICAO, EASA, Transport Canada, ANAC, you name it, any of them, where there are acceptable means of compliance, usually they call out a standard. And those standards include SAE International standards to show a means, but not the only means, of compliance to meeting the regulations. SAE International contributes to industry expert panels on important UAS issues at AUVSI Exponential. And it also contributes to the NASA AAM working groups and the Vertical Flight Society Flight Test Council. On the right side of this chart, you can see some of the cover pages of some of the documents that have been published and some of the things we've contributed to. So in the next slide, we're going to dive deeper into the SAE International Standards Developing Committees. Now, I want to emphasize that there are over 200 SAE International aerospace standards developing committees. They cover everything from the raw materials and the very the ground-based systems and the ground support equipment, all the way up to the systems of systems and the airborne systems. So it covers a wide gamut, a wide spectrum of aerospace products and services and methods for both not only just aircraft, but also the ground supporting equipments and the supply chain and the raw materials and the more complex systems. So on this chart, I'll just there's a link to this org chart, and this is the Aerospace Council organization chart. And what you see is the various different groups. You have the General Projects, Aircraft Systems Group, Electronics and Electrical Systems Group, the Mechanical and Fluid Systems Groups, the Avionics Systems Groups, the Propulsion Systems Groups, the Materials, and then down here in the lower left, Reliability, Maintainability, and Health Management, and then Airport and Ground Operations. And then on the lower right, you have the Systems Development, Safety, Component, Process, and Management Systems Group. And these committees are all labeled with a prefix, letter, and number, and then a title of the committee. And the colors on this chart associate those committees back to a point of contact, which we refer to as an SAE committee manager. And those SAE committee managers are listed in this table at the bottom in the center. So back to our presentation. Again, I wanted to emphasize that there are over 200 of these committees, and they cover, the wide spectrum of aviation-related topics, aerospace-related topics, and a UAS is an aircraft. And so if you're going to design, develop, certify, build a UAS, you're building an aircraft. So there are thousands of SAE standards that go into the design, the development, the production, the operation, and the support of an aircraft in the aircraft ecosystem. So many of those standards apply already, just as they would to a manned aircraft because it's an aircraft. Now, there are some specific provisions for UAS, and there's some specific aspects of UAS that make UAS a little more unique. And with that, some of this, I handpicked some standards committees that have some specific documents or have documents specifically for UAS. So we're going to just dive right into those committees and those documents. Now, as mentioned before, like just before me, Ravirajan mentioned the ARP 4754 and the S18 committees. Well, this is an overview of that committee. S18 is a joint international committee with EuroK WG63, Aircraft and System Development and Safety Assessment. It brings together qualified specialists for the advancement of aerospace safety and to support effective safety management and development processes. And this table below shows those works in progress that they currently have. Now, at the bottom, I will use this laser pointer to show you, you have the ARP 4754B and ARP 4761A. The letters B and A indicate that this is a revision to these standards. And these are highly anticipated documents, highly anticipated revisions that will be coming out, we expect, in 2022. And these documents are referenced as means of compliance to regulations across the globe. They're also used in military or defense and space applications as well. And then they also have some new documents they are working on. This one for using STPA, and this one for use of modeling and tools for the aircraft systems development. So if you're using like modeling and tools and like software tools and design tools. And then AIR 7209, this one's also highly anticipated. It's a development assurance principles for aerospace vehicles and systems. This one is a great document, especially for advanced systems and new systems that are coming out. And this was also at the request of the general aviation community. Okay, so on the next slide, I'm going to introduce this working group under S18. It's the S18A Autonomy Working Group. And this is to support type certification of UAS, including urban air mobility vehicles, which are typically like your eVTOL aircraft as well. So S18A is currently identifying specific gaps in both ARP 4754 and ARP 4761s, the ones I mentioned on the previous slide, that affect UAS development and the domains where those gaps should be filled, and would provide a common understanding of necessary guidance needed to support the development, assurance, and system safety of UAS for both developers and regulators. So this is their work in progress, that's happening right now. Okay, so the next slide is an overview of G34. I believe you probably heard Mark Groboff speak about this already, but if you're just joining us today, again, G34 is a joint international committee with EuroK WG114 on artificial intelligence in aviation. It focuses on the implementation and certification related to AI technologies for the safer operation of aerospace systems and aerospace vehicles. They published their first standard on April 30th of this year, and they have 3 works in progress that will follow. Now on the right side is a depiction of a house, and this house has a strong foundation of these documents that they're developing. And then you could build upon that strong foundation and build a room for the aircraft and UAS certification solutions and the air traffic solutions. And then above that, you have the subgroups. And then above that, you have the committee leadership, all under the roof of SAE and EuroK. So that's the analog to the structure of this committee. So this committee all has references by these important roadmaps and documents. So all of these published reports here call out and annotate SAE G34 and EuroK WG114 as the standards committee to develop standards for AI in the aviation ecosystem. This includes the ANSI standardization roadmap for UAS, the EASA AI roadmap, the EASA concept paper, the AVSI report, the Fly AI report, and NASA's upcoming AI roadmap. So they reference SAE G34 and WG114 as the standards committee to develop standards for AI in the aviation ecosystem. Now this slide discusses the A6A3 flight control and vehicle management systems. This is a subcommittee within SAE A6, which is a very large committee. They've been around for many years, dating back, I want to say, to the 1960s. And they develop standards for aerospace actuation, control, and fluid power systems. They address all aspects of aerospace flight, utility actuation, control systems, as well as fluid power systems. They have 3 subcommittees, and they're working on a document for the flight control design, installation, and test of military unmanned aircraft. This next committee is the AS4 JAWS. It is a message-based architecture that defines data formats and methods of communication among commuting nodes. The architecture defines messages and component behaviors that are independent of technology, computer hardware, operator-used communications equipment, and vehicle platforms. This is committee, and the next committee, AS4 UCS, are standards committees that are developing products specifically for the United States Department of Defense, but their standards could be used by anyone, including civil domains as well. The E39 Unmanned Aircraft Propulsion Committee published their first standard. It's ARP 6971. This is power and torque determination for UAS engines. And so this sets a standard for determining, the aircraft, or excuse me, the engine performance. A20B Exterior Lighting Committee. This committee developed a standard for lighting applications for UAS. AC9C, this is the Aircraft Icing Technology Committee. So this deals with airborne de-icing, so the aircraft de-icing, not to be confused with the ground-based de-icing, which sprays aircraft with de-icing fluid. We have that committee as well. But on this committee, this deals with the in-flight de-icing. And so they're working on a document called AIR 6962, Ice Protection for UAVs. Next slide, AE8A, Electrical Wiring and Fiber Optic Interconnect Systems Installation. They have a document for wiring, for all types of aerospace vehicles, and they're analyzing impact of high voltage on wiring as well. So where could we get all of this stuff? It's accessible on SAE Mobilis is a great research platform, as well as SAE.org. So this helps you search for all kinds of content, anything from standards to tech papers, journal articles, videos, courses, just about all the types of content we have, and books as well, edge reports. So I'm just going to shift gears really quickly here and talk about and answer this question. Where do SAE standards support the ANSI UAS standardization roadmap? which you will see in the next presentation. So to just give you a primer, this ANSI UAS Standards Collaborative, referred to as the UASSC, its mission is to coordinate and accelerate the development of standards needed to facilitate safe integration of UAS into the national airspace with international coordination and adaptability. This group has published a roadmap in version 2 in June 2020, and identified 71 open gaps with no published standards, and identified accompanying recommendations. And now to fill these gaps, and also it also identified the applicable standards as well. So I'm just going to walk through this, and I'm going to just jump to Chapter 6 of this roadmap, because Chapter 6 has significant sections that pertain to type certification of UAS of all sizes, complexities, and operations, including jumbo jets. So this is an outline of those chapters. And if we just walk through this, say 6.1, design and construction, well, how does this relate back? How does SAE standards support that? Well, we have SAE 1001, ARP 4754A, AIR 7209, numerous SAE AMS committees that publish material specs, composites, additive manufacturing, fasteners. There's also numerous committees that publish aircraft system standards for landing gear, electrical systems, propulsion, flight controls and actuation, etc. Then if we jump down to the UAS system safety, of course, you have your ARP 4761, and then for continued operational safety, you have ARP 5150 and 5151A. For quality and assurance and quality control, you have the family of AS9100 standards, which is the quality management standards, as well as the counterfeit avoidance standards. Those include G19, G21, G22, and G33 configuration management standards as well. Then when you look at command and control link and communications, there are numerous SAE ITC ARINC standards that can apply. Navigation systems, we have the SAE PNT committee, position, navigation, and timing. And these standards are listed here, as well as the SAE ITC ARINC standards. PNT has launched a specific standard to fill these gaps identified in this roadmap, and it's SAE 1026. This was just launched, the standard. Next, we have systems performing detect and avoid functions. I jumped ahead. This should be pointing to the software considerations. And this group of standards is for voice and data recorder systems, cybersecurity, the G32 committee developing these documents here, listed here. And for electrical systems, there are several committees. Many of these are the AE committees, like aircraft electrical, aerospace electrical committees, 2, 4, 7, 8, 9, and these new high voltage committees, such as AE10, AE11, and then of course A6 and A20 tie into electrical systems, especially with flight control systems and electromechanical actuation. Power sources and propulsion, there are SAEs, there are many, one of our biggest strengths in standards is in propulsion systems. So there are also very many committees developing standards for propulsion systems. And then for noise emissions and fuel venting, we have a noise committee, A21, E31P on particulate matter, and AE5 on aerospace fuel inerting lubrication systems. And then to protect aircraft, we have ice protection, icing technology, aircraft ground de-icing, the G12, and lightning committee to protect aircraft from lightning strikes. And then at the bottom here, we have the AI and autonomy, and those comprise of SAE, S18A, and G34. And then again, for continued operational safety, we have these standards. And then have the commercial services as well. Ritesh will talk a little bit more about this. And then on chapter 10 for like UAS flight crew, we have these standards and these committees as well. So that concludes my presentation. I thank you for your time and this opportunity to speak today. And if there's no time for questions, I'll be happy to answer them. You can email me at mark.d'angelo@sae.org and answer some questions.
Okay, SAE team, is there any questions for Dr. Mark?
There are no questions.
No questions. So thank you, Dr. Mark. That was a UAS visit to the US or from the US. Thank you.
You're welcome.
Thank you for your time and presentation. Ladies and gentlemen, we are a little overboard. That is about 7-8 minutes. So we are now taking a deep dive into the UAS world. Next comes the talk on overview of ANSI standardization roadmap of UAS V2 and FAA perspective. So we bring you the custodian on this. And Mr. Ritesh, are you online?
I am,
Okay.
thank you.
So hold on, sir. So the second name, I wanted to pronounce it right. Is it Ritesh Emere?
Yes, sir, you are all, yes, correct.
That's the way they do it in Nepal, right? Thank you. So, ladies and gentlemen, Ritesh Emere has been actively supporting the FAA, UAS industry, ANSI, NASA, and leading outreach of the ANSI UAS standardization roadmap to support the FAA's global leadership. He is the custodian of ANSI UAS standardization roadmap. He has been actively supporting development of industry standards needed for type certification of UAS. He is the recipient of many awards, including ANSI's 2020-2021 Leadership and Service Awards in the Meritorious Service Award category. Ritesh, a US Army veteran with a BS and MS in aerospace engineering, has been working at the FAA UAS Integration Office as an aerospace engineer, developing UAS policies and certifying UAS. He worked at the FAA Aircraft Certification Office on type certification of transport and small category aircraft. Ritesh has been supporting various UAS programs like Boeing MQ-25 and Camon K-MAX as the UAS integration lead. He was also involved in the certification of UAS from Boeing, General Atomics, Lockheed Martin, Northrop Grumman, Google Titan, and many more. Ladies and gentlemen, here it is, Mr. Ritesh Emere. Over to you, sir. Floor is yours.
Thank you all. Thank you, SAE India leadership, SAE India members, and the attendees of this meeting. And special thank you to Dr. Ravi Kumar and Dr. Dinesh Manoharan for giving us this great opportunity to present the great work of the team comprised of 400 plus people from 250 plus companies. Let me share my screen really quick. So are you able to see my screen?
It's still coming up, Ritesh Emere ji.
Okay, no problem.
It's still coming.
Okay, no problem.
It's
I
coming.
apologize.
Presentation view. Good to go. Over to you.
Okay, sir. Thank you. Thank you all. We are really thrilled to get this opportunity to brief the great work of the team and volunteers. And first of all, I would really like to shout out at Jim Makabe. He is the Senior Director for Standards Facilitation at the American National Standards Institute, the ANSI. And also, I would like to, express our gratitude to the 400 plus volunteers from 250 plus organizations that have been passionately helping and dedicating their, personal time to really enable this unmanned aircraft systems integration, or UAS industry group. Thank you all. Okay, so this slide shows that this collaborative, right? The ANSI UAS Standardization Roadmap Collaborative, or in short form UASSC. So this collaborative work is constructed just like the SAE committees. We all represent as an individual, and this roadmap work is an individual contribution. And the views expressed by the individuals in this publication do not necessarily reflect the views shared by the companies they are employed by or the companies mentioned in this publication. And also this roadmap is the publication of the ANSI, all rights reserved, and anyone interested to talk about copyright and this kind of activities, they need to contact ANSI, the ANSI. So this slide shows the great team-spirited at an enterprise level work from 400 plus passionate volunteers that are have been dedicating their personal time to really support and enable safer, faster, and secure integration of UAS into the sky of any country. And these volunteers, passionate volunteers, they are from 250 plus organizations, and the version 2 of the roadmap was published in June 2020. This version 2 roadmap has 71 open gaps. Open gaps means there are no standards. And obviously, we would also like to thank Mark to kind of give the primer type of information about this roadmap, and also linking that to numerous committees of SAE group. So as you can see at the center of this slide that, there is a little cartoon there, and the cartoon here also signifies that this is a teamwork. And there is no one player, no one person, this is all teamwork. And the left column shows like a, stuff like a semi plus circles, also to signify that this is a teamwork at an enterprise level across the globe. And we received a lot of great and honest feedback from passionate volunteers, that have been dedicating their time and service to really promote safety and improve safety in the aviation. Exactly is the UASSC. The ANSI UAS, obviously unmanned aircraft systems, or drone, or remotely piloted aircraft system, RPAS, or UAV, unmanned aerial systems. So the ANSI UAS Standardization Collaborative is abbreviated as the UASSC. And this collaborative, the reason that we have this word collaborative here is to really depict and signify that this is a collaboration work. This is a teamwork, collaboration work. So without collaboration, it is very difficult to really enable newer and advanced technologies, right? And obviously we have the word standardization here to signify that this is the roadmap of all the standards activities about who is doing what in terms of standards pertaining to unmanned aircraft systems, approval, certification, authorization, and obviously finally integration. So this standardization collaborative is a mechanism to advance cross-sector coordination. Here, cross-sector means public and private, That's what it means, right? Cross-sector coordination in the development and compatibility of standards and conformance programs needed to support emerging technologies like UAS, and also to support national and international priorities. And obviously we know, like India, being a major player, and a lot of things are also advanced technologies and advanced engineering activities are also happening in India. So this is very relevant to India as well. And here, obviously, we have this word compatibility of standards, right? And what that means is, like Ravi mentioned earlier this morning, that we are really the roadmap is again really encouraging globally harmonized and interoperable standards. Again, I'm using the word encouraging, right? The roadmap does not task anyone, does not instruct anyone. So this is like they only encourage. You are highly encouraged to address or refer to this roadmap. So what is the mission of the UASSC, right? The mission of UASC is like, here it's a very lengthy sentence, but in short and sweet, its mission is to really support rapid, I repeat the word, rapid development of needed industry standards to really support UAS certification of all sizes, complexities, and operations. In another word, we call UAS integration into the national aerospace system with international coordination and adaptability. Again, here, the key here, right, the globally harmonized standards is the key. And as you can see on the right side here, that we have a cover page of the version 2 of the ANSI roadmap, in which there are three graphics, right? The first one on the far right shows that it is a large UAS, unmanned aircraft systems, and on the left here shows like a small UAS, right? And in between shows like, the medium-sized UAS. So this is to show that the scope of the version 2 of the roadmap is, to address the UASs of all sizes, complexities, and operations. Again, the word, we are using UAS as a generic word, right? AAM, UAM, IAM, RAM, they all are also included. And why a roadmap, right? So this was a very challenging situation. So prior to 2017 May, it was very difficult to really understand and gauge what were the activities happening, with respect to UAS integration or UAS standardization or UAS standards development work, right? So there were no consolidated or unified place that one could go, right? And thus, that was the reason for creating this roadmap initiative or idea, was that many standards developing bodies, right, we call SDOs, are involved in UAS. So this was the reason for, for the leaders from FAA as well as the industry and other stakeholders, to really like energize the momentum to create this UAS standardization collaborative. And as you can see here, we have, ASTM, ISO, RTCA, SAE, IEEE, and it goes, on and on. So this is just the few that are listed that have been involved with UAS, but there are others also. There are a lot of standards developing organizations or standards bodies. So this slide here is to show that larger and complex UAS as use cases are mentioned in the version 2 of this roadmap, and specifically the green in-boxed for use cases signify that they are very nicely aligned with the existing regulatory framework. Small fixed-wing aircraft, a large transport category fixed-wing aircraft Part 25, rotary small product Part 27, or in terms of like EASA regulation CS or Part 29. And the theme of this slide, right? And the version 2 of the roadmap is that this roadmap really enables UAS of all sizes, complexities, and operations, leading all the way up to large transport category aircraft like turboprop, right? I mean, big aircraft with jet engines. Obviously, big, fixed and rotary product like military, V-22 type of aircraft. But so anyway, so inside this inboxed 4 use cases, right? This collaborative and team, right, comprised of 400 plus people, we chose the word transport, for example, in section 8.4.2, to sort of signify that this use case pertain to part 25 type of aircraft or category of aircraft, right? And similarly for section 8.4.3, urban air mobility or advanced air mobility, is to signify and sort of again, map with the existing framework we have, right? Whether the regulatory framework or the industry standards, right? From SAT committees and other committees. So, and obviously the section 8.4.4 is the commercial passenger transport. And here we have 2 keywords, right? Passenger and transport. Transport means part 25 category aircraft, and passenger means obviously, this is the use case to carry passenger. And in the in section 8.4.2, we have the word cargo, and that is, the future, part 25 type of aircraft conducting operations, to haul air freight from point A to point B for, companies like a DHL, UPS, FedEx, things like that. And obviously this section, the last section here, section 8.4.5, this is very important, right? Because this deals with sensing services. And obviously we borrowed this word sensing from the military side, remote sensing kind of operations. And here is to signify that this, fixed wing and rotary products category aircraft or unmanned aircraft systems, can be used to really support, police, government, or, other private companies or industries to really support the mission, right? For example, the weather service, right, of India, or the police department, right, of Chennai or Bangalore or Delhi. So like a private companies, right, they can conduct this operation to support, either private companies or government, federal, central government, state government, local, city, and metro. So in summary, right, this section or the scope of the roadmap is the UAS of all sizes, complexities, and operations. So this slide here shows that the standards are needed to really support the remote control station, in parenthesis, control station CES, of UAS of all sizes, complexities, and operations. And the control station, topic is placed under section 6.1, design and construction. And again, this section really encourages, right? Again, we do not task any committee or working body or organization. This section really encourages industry to get together to start thinking about also developing needed standards to address the remote control station. Okay, and this slide here, right? The first bullet point on the top is very important here. And this slide is the historical event of this UAS-SC and the UAS standardization roadmap. So so UAS-SC was established in May 2017, following meeting with the FAA and other stakeholders. And then we had, first kickoff meeting in September 2017. The leadership were chosen to represent public-private partnership, and then we published the first version 1 roadmap in December 2018. And in September 2019, we initiated the version 2 kickoff meeting in Washington, DC, face-to-face meeting. And last year, June, we published version 2 of the standardization roadmap. And just a few months ago, in June 2021, ANSI published GAPS progress report. And this GAPS progress report is 47 pages long with full of tables about which committee has published what document in the last 1 year or since the publication of version 2 in June 2021, and which committees have created new work in progress or WIP, or in development standards. So this GAPS progress report will be very handy for all of you, especially all of you being like engineers and scientists working for government think tanks and industry in India. And this is a very slick document, and obviously version 2 of the roadmap is 412 pages long, but very thorough, comprehensive, and it highlights, activities of all the standards bodies, lot of pertinent government agencies, international entities that have been directly and indirectly, involved in the UAS or drone standardization and integration. So again, I think I have kind of already covered this slide, but just to recap, right? The ANSI UAS Standardization Collaborative is a mechanism to advance cross-sector coordination. This is again to emphasize the teamwork here. In the development and compatibility of standards and conformance programs needed to support emerging technologies and to support national and international priorities. And I think Ravi kind of highlighted with special focus on the conformance part also, as well as Mark mentioned about some of the QA/QC standards from the committees. So anyway, here, right, the most important point here is the red font text at the bottom, right, the last bullet at the bottom. So the actual objective of this roadmap is to really avoid duplication of standardization effort, right? So there is no point, different companies working on same topic using same resources or different resources, right? So again, this is really to encourage, right, all the users and stakeholders to, be aware of who all are doing what all activities, and for them to make informed decision. Because a lot of these standards works are volunteer-based works and activities. So this is the structure and participation. So on the top we have a steering committee, and the steering committee is the governing and leadership committee for this collaborative standardization collaborative, and then we have 4 working groups. Working group 1, WG1, is the airworthiness, and the remaining 3 are flight operations. Dealing with public safety, inspection, use of UAS for inspections, environmental, agricultural applications, commercial services, workplace safety, general concerns, personnel, certification, and so on, right? And so anyway, but I think for this audience, and since all of you, most of you are engineers and scientists, I think the WG1, Working Group 1 airworthiness, is very much pertinent. And Mark had already shown the different constituents of the Working Group 1. But so anyway, the participation is open to US stakeholders that have US operations for support at the working group level activities, right? And these working group level activities are kind of like SAE committees or any standards committees, right? That's where a lot of the things happen and gets decided. And then obviously ANSI membership is not a prerequisite. And even though the participation is open to US stakeholders that have US operations, at the working group level, we really encourage all of you, and we would really appreciate for us to continuously improve and learn. Thus, we kindly request you to go to, ansi.org/UASSC, and there is one, link there. I think maybe 20% from the top, right, when you scroll down, and we are still collecting feedback. So even though version 2 is published, and right now we are in like, hiatus mode. We are still collecting feedback. Please provide your honest feedback as a passionate engineer and scientist that have been, involved in the aviation ecosystem, and specifically to improve the safety of the aviation ecosystem. So participations, come from the entire aviation ecosystem, including think tanks, government agencies, standards bodies like SAE, other interested stakeholders, and any other, individuals, right? Whoever is interested, this is an open forum, and obviously ANSI membership is not a prerequisite. So like I mentioned earlier, this is a great, this is a product. This is a great example. This is a great example of the enterprise level teamwork from 400 plus people from 250 plus organizations. So what are the working groups? So working groups are just like SAE committees, right? That's where we roll up our sleeves, sharpen, pencil, and start solving problems. And this roadmap is very strategic and very technical. So for example, right, there are a lot of sections that deals with air traffic integration, and a lot of sections that deals with pilot related activities like human system interactions, human factors, the flight crew, interface. So those sections, right, if it is a pilot related sections, it is very, technical for pilots. I'm not a pilot, I'm just an engineer, right? So, and that's why like it has basically everything that, that are needed. And even though the title of this roadmap is the Unmanned Aircraft Systems, UAS Standardization Roadmap, but a lot of the technological and topical areas are common. For example, level of automation, autonomy, and artificial intelligence, cybersecurity, right? Collision avoidance system, software, avionics, navigation system, detect and avoid. So there are a lot of areas, that can be still applied to outside of UAS activities. So here, right, a gap means no published standard that covers the particular issue in question. And obviously at the working group level, we identify published and in development standards, describe in development standards, and should be developed standards as gap. And obviously we have this flow chart that we use to identify and justify that there is a gap. And obviously sign up for more than one working groups can be done at www.ansi.org/UASSC. And again, even though the working groups are open for US-based operation, companies with US-based, but we always welcome. And a lot of you also work for a US company, but based in India. So again, this is really a teamwork. And this slide here shows the process flow for describing issues and gaps. And again, here gap, gap is here also correlated to need. So the question we should always ask is, do we really need a standard, right? So here we are not talking about the want or wish or prefer, right? So here the need and gap, we cannot separate, they are inseparable, right? And this is very self-explanatory. And we start with describing the issues, and then we list, any published standards. And if the published documents or standards address the issue, then stop, no gap, right? And that means no need. And similarly, we also, attach this R&D needed question, yes or no. And we use, the prioritization metrics to evaluate the different priority level, high, medium, or low. And then we also tag along with the list of recommendations on how to address the gap, as well as the listing of organizations that can address the standards gaps and the associated R&D component to it. So this is just like two components that we use for calculate, in our prioritization metrics to calculate the composite quantified value. And in this case, we use case. C stands for critical aspects, right? It deals with safety, quality implications. A is whether we can achieve or not, or time to complete, and the corresponding numerical values. And then on this slide, we kind of mentioned about the scope, right? Investment of resources, right? This scope is very important. And so is the effect, right? The last point here, our component, is the return on investment. So this is, again, where we really evaluate what is the benefit, right? I mean, is there really a need, or is someone just talking about the want, right? WA1 versus WANT versus NEED need, right? And as you can see on the bottom row here, we use the composite quantified score, and that will automatically point the needle towards high priority, medium priority, or low priority. And again, the main mission of the ANSI roadmap is to coordinate and accelerate the development of the standards and conformity assessment programs needed to facilitate the safe integration of UAS into the NAS with international coordination and adaptability. And version 2 was published last year. It has 71 open gaps. Open gaps means no published standards. And all these 71 gaps are tagged along with a set of recommendations. And the right-hand column here is the cover page of the version 2 of the roadmap. And so there are 3 objectives for this collaborative work. The first is to foster coordination, collaboration, and harmonization among all the players or the constituents of the entire aviation ecosystem. And the second bullet point here in the middle is really like to clarify what it really means is like, it really encourages avoiding duplication of standards, activities, and efforts, right? And which states, the second point here is to clarify the current and future standardization landscape and enable stakeholders to better focus standards participation resources. And the final point here, or the objective here, is to provide a basis for coherent and coordinated US policy and technical input to regional and international audiences on UAS standardization. So this slide here kind of, shows presents the complement of the great work, that have been, that Jim McAvey from ANSI has been leading. And he was kindly invited by NATO Greece February 2020 meeting to provide an overview of the version 1 of the roadmap, because that time version 2 was not published. And the participations of this meeting were all basically standards bodies from the DoD, NATO, standards development organizations, ANSI, European Commission, foreign regulators like, EASA, among others. And there is a picture and the link. And the workshop recommended that NATO establish a joint forum to foster networking and cooperation between NATO SMEs and their counterparts in standards organizations' technical committees. And the second was to identify priority areas where potential cooperation will improve the quality of standardization products. And obviously the last was to do better harmonization and collaboration. So so this slide here shows that a delegation of government of Vietnam flew all the way from Vietnam to Washington, D.C. to get briefing from FAA and ANSI in September 2019. And the SDOs were also present, and obviously SAE was also present there. And this slide here shows that FAA was invited to brief Indian Ministry of Defense, DRDO SEMILAC. It was a government briefing, and we briefed about the version 2 of the roadmap.
Mr. Ritesh?
Yes, sir.
Sorry to interrupt. We hate to do this, but we are running behind the schedule, so we need your support.
Understood. How much time we have?
We're already behind, so
okay,
another couple of minutes, if you could. Thank you, and sorry about this. Sir.
Yeah, no problem. So, okay, so let me go to this, right? This slide shows the harmonization of US activities and both standards, industry standards activities and ANSI US roadmap are industry activities, and they are two players of this big teamwork to really support certification and approval. And this slide shows that roadmap is leading US integration activities. Again, ANSI roadmap and its industry standards activities are industry activities, and they are nicely aligned with the FAA regulatory framework, ultimately with the aim of supporting certification. And again, the hottest topic is the detect and avoid, right? This is the hottest topic in US integration. And we have RTCA SC228 that is developing DAA, C2, and US navigation system standards. And similarly, we have ASTM F38 committee developing DAA standards for small UAS. And just to highlight here, right, that ops over people using small drones, that is on section 7.4. It is aligned with FAA regulation. And similarly, section 7.8, remote identification of small UAS, that is also aligned with our new part 14 CFR part 89. And again, this slide shows the use cases. This is the repeat. This is again general concerns. Here, the important one of the most important topic here is the US mitigation and detection, which is counter US technologies. And this section deals with human factors activities. And these are some of the key players and contributors, right? We have US industry, regulators, DoD, NASA, NATO, EDA, ICAO, experts, among others. And this section deals, this is just a copy paste from the ANSI roadmap that about AI section. And this has the list of operational and integration challenges that some of which we need to address at the design, development, and certification phase of unmanned aircraft. So again, this is what it looks like. I'm gonna go, and this slide is very important here. This is the harmonization slide for AI activities. And all these three documents are developed by industry as a group. So this is a teamwork from industry, right? And this is the way to get free copy of ANSI UAS Roadmap version 2. You can just go to step 2 inside the box, the SurveyMonkey website, and you'll get this page, and then put your information, and then you can download a free copy, PDF copy of the version 2 of the roadmap. And this slide here, you can copy and paste this, or you can type this, the link that is shown inside the box in item 3, and you will get this page. And when you get this page, you need to just click that, red broken line there, twisted line that shows gaps progress report. And this is a PDF document, 47 page long. And you may want to save this in your personal computer as well as work, because this is very sleek document, and it has a lot of condensed information about everything about US standardization activities that we have, copied from the 412 page long report. And again, this is just to recap that, this is the copyright of the ANSI, and this roadmap work is an individual contribution, like SAE committee's activities, right? And here is my contact information with my email address. And if you're not able to, contact me directly, you can reach out to Dr. Ravi Kumar or Dr. Dinesh Manoharan or others at SAE India or SAE India Leadership. Thank you all. We really appreciate your interest, and we look forward to getting your continuous feedback, and also, comment whenever we do next version. Thank you all. Good night.
Thank you, Mr. Ritesh Shimare. I think that was a far-reaching perspective. That was a packed session. So, ladies and gentlemen, members and guests, having simulated enough interest in you about standards, guess the next topic. What else? How to get involved in SAE standards development, right? I'm an aero engineer, spent a decade or two. I'm a specialist, subject matter expert in something, and now I like to contribute, give back to the world, give back to the engineering community, the mobility fraternity, especially aerospace community. Then what do? Eureka! SAE International Standards Development Committees, that's the answer. And ladies and gentlemen, we present you Ms. Kerry Rohal. Kerry Rohal is Standards Manager at SAE International with almost 20 years at SAE. 20 years. I want to meet you, Kerry. She started as an aerospace. Sorry, I'm just completed 5 years in SAE India. That's a world of an experience. Kerry started as an aerospace standards specialist working directly with our standards committees. In Kerry's current role, she is responsible for the management of standards specialist team covering both aerospace and ground vehicle sectors, ensuring adherence to our policies and procedures and coordinating the proactive production of SAE technical standards. Kerry has a bachelor's degree from Clarion University. Over to you, Kerry. The floor is yours.
Thank you very much. I appreciate it. As you had said, I'm Kerry Rohal. I am the standards manager here at SAE. I appreciate the opportunity to share with you all and to also invite everyone to to participate in our committees. Did you want me to pull up the presentation on my end, or are you pulling it up on your end?
Yeah, from your end, can you pull it up or?
Sure. Yeah, absolutely. Yeah.
That will be good.
Yeah, and also, Kerry, sorry to interrupt. There is one announcement, members and attendees. We are running little behind the schedule, but we have started the parallel session 2. If you're interested in that, you can move it. Kerry's session is about 10 minutes. So just wanted to let you know. Over to you, Kerry.
Okay, and I should be able to give you guys back a few minutes, I think, of the time. So jump right into it. So this is quite an eye chart. So I realize that it's probably difficult to be monitoring screen, but this is our organization chart that shows all of the committees that are currently under our Aerospace Council.
Kerry,
Yes.
sorry again. I think you have to put the full view. We are getting 2 charts. You can go to the duplicate and then on the top, second.
Let's see. Maybe if I do that.
Yeah, 5 will do, yes.
5 will do.
Yeah, but we are not seeing any slides, Kerry, now. So.
I think she has a connectivity problem, looks like.
Yeah, network
connection. Or shall I share? That's can share that.
Kerry, I think Dr. Ravi has shared from India, so you can go ahead and you can request Dr. Ravi say next slide. Is that okay with you?
Yeah, I can do that. That's fine. Yep. Is that easier? Yeah, I don't, my system seems to be frozen. It won't let me move the presentation. I apologize.
Okay.
We are on the same slide, so go ahead, please. Technical committees.
Okay.
Yeah.
Okay. So as I had said, okay, so this is the actually plug this in so it doesn't die here. Sorry. This is the organization chart. I believe during the last presentation, my, can you guys see it okay? Because I can't see it right on my screen.
We can.
You can see it? Okay. Thank you. I believe during the last presentation, my coworker, Mark D'Angelo, had actually sent the link in the chat to this chart. So if anyone wants to take a closer look, but as I had mentioned, this is a list of all of the current technical committees that we do have under the aerospace sector. You can go to the next slide. So we have 3 different types of statuses on our current committee rosters. So a voting member is just that. We're looking for them to vote when a document is going through the balloting process. We ask that they do attend the meetings. Obviously, lately our meetings have been all virtual, but we do ask that they attend face-to-face when those meetings take place. We ask that they respond to ballots and maintain an active participation. So participate in any decisions and discussions that are taking place. The second role is a liaison. Is where they do receive the ballot notifications, they do review the ballots, and they can make any comments that they have, but they don't have a formal vote. So those that have a formal vote are only those that have the voting member status. And then the third is the mailing list, so which is kind of limited access to StandardsWorks, and I'll get into what StandardsWorks is in a few slides. Those folks are just kind of on our committee rosters to maintain, you know, they're interested, but they may not be able to actively participate for one reason or another, but they do just want to keep aware of what we're working on and what's happening. So they remain as a mailing list recipient. Next slide. Okay, so the benefits of participating with our committees, obviously a big one, and one that we have truly missed in the face-to-face world in the last year and a half, has been the networking. So, you know, you get to network with customers, with partners, with folks from our regulators, you know, meeting new people and working together, not only on the SAE standards, but maybe even things outside of the SAE arena. You get to gain an overview of the industry. Again, you're sitting around the table with technical experts from around the world, so you're getting their feel and their takes on things, learning about state-of-the-art technology, keeping informed of what's going on in the standards world. So again, learning from each other and working together to build those standards. And then also, again, you have that seat at the table so that you're able to influence the global market and contribute to how these standards are written and developed and then put out there for industry to use. Next slide. So typically our committees, they typically hold, and again, obviously this is in a pre-COVID world and hopefully a post-COVID world sooner than later. But typically our committees do meet twice a year face-to-face. Normally that is in the spring and the fall. That's the spring and the fall timeframe. That's not to say we don't have committees that do meet in the summer and winter months, but a lot of them do meet in that spring and fall timeframe. Some of the things that you would typically see on a meeting agenda for a technical committee would be obviously the development and discussion of standards. They provide updates on, again, updates that not only on our standards, but things that are going on in industry, or maybe something that they've learned or heard from their own companies that they want to share with the committee. Discussing new technologies, anything that's coming up on the horizon that they want the committee to be aware of, or something that would maybe where a new standard will be needed. And then developing committee strategy. So obviously the best way to get the work done that they do have on, you know, in front of them. When we do create a standard, whether it is a new standard or we're revising an existing standard, we do typically have a volunteer from the committee who is what we call a document sponsor. And he takes that lead on running that project. So while he's obviously still working with others on the committee, and then it does go out for a formal ballot to the entire committee, he kind of takes the role as the lead in getting the document going and making sure that, you know, nothing's falling through the cracks and that it's moving forward in a timely manner. Again, the last comment, over the last year and a half, we have been having all of our meetings really be of a virtual setting. I will say, while it was obviously a change for all of us to not have that face-to-face time, our committees have done an excellent job at adapting and still being able to accomplish what they set out to accomplish, working these standards, having, you know, some great discussions, even in a virtual setting. Next slide. Okay, so this is just kind of a quick snapshot of how we develop a SAE document. So obviously there needs to be that need from industry, and that need then is shared with the appropriate committee. The committee then, again, kind of, you know, gathers around and decides how and what, and, you know, how they want, what information they want in the standard, how they want it to read, etc. When it is at the committee level, it does draft document, and then it does go through our formal balloting process. Some documents pass the committee level first time through, some it does take a few times to get through. Because we need to resolve any disapprovals that might be received. We need to resolve any comments or discuss comments that may come through. So a lot of work takes place at that committee level to get it to what we wanted to read it, once it's published. Once it has passed that committee level, then it does go on to a second level of balloting to the Aerospace Council. And the Aerospace Council is the governance oversight group of all of our technical committees. They also ballot the document, they vote on it, they can comment, and then depending on how that ballot goes, if anything needs to be discussed, resolved, we take care of that. If everything passes first time around, then we move it on to publication, where then it is available for use. Next slide. So Standards Works, like I had mentioned before, this is the current system that our technical committees use. It is basically a one-stop shop for all of our technical committees. So I realize, again, the screenshot on the right may be a little harder to read, but it is where all of our committee members go for anything they may be looking for. So as you'll see, the column on the left, there's the resources. So that's anything like our policies, procedures, style manuals on how to write a document, different SAE information that we think that our committees will find valuable. The middle column is the upcoming meetings. Obviously, this is an older screenshot, but this is typically where we put our meetings and anything future meetings that are coming up, whether they're online, whether they're face-to-face, and all the details pertaining to that meeting. And then the third column is those meeting minutes and presentations. Our current retention policy is to hold those for 5 years. So we do have 5 years worth of meeting minutes on each committee's page. The top of the screen there where you'll see, so this is obviously the additive manufacturing Standards Works page. The blue tabs that go across the top, again, are different pages of information for that particular committee. So right now we're looking at the main tab, but the next tab over would be the WIP, which is the work in progress. So that's any documents this committee is currently working on. The document tab would be a listing of any documents this committee has published. The committee work area is just that. It's an area for the committees to work and post information that they may want to, have the committees look at or review, etc. The roster, again, is a listing of all of the folks that participate on this particular committee. And then the ballot tab is obviously where we have all of our ballots. We keep all of our ballots posted on this site until the document is published. And then per our retention policy, they do get taken off. And then the last tab is just the email tab. So again, it's an email functionality that is used so that us as staff can email our committees, committee members can email everybody on the committee, whether they want to email the entire group or just a select few. So there's an email function there. So again, this is kind of where they do all of their work. I will note that this system, the current Standards Work system, is currently being updated. That is something that we're currently working on here at SAE with staff and also working with some of our users to get some testing and feedback, et cetera, with the hopes of rolling out the new site sometime next year. Next slide. Okay, so basically how to get involved. So I think very, very importantly that it's understood that the process is open to everyone. We welcome everyone to participate, to be vocal, to have a seat at the table, and have your say in these standards that are being developed. So kind of exactly what that second bullet says. We welcome your involvement. We welcome your participation. You're welcome to attend. You're encouraged to attend. Again, most of our meetings right now are still virtual, with only a handful being kind of that hybrid face-to-face and virtual. But that is with the hopes that obviously if things continue to get better, we will get back to having these face-to-face meetings at some point next year. You're welcome to contact me, and my information will be the last slide. But we do have, that's me. But I also, on that chart where Mark sent the link and also is in the very beginning, like I said, I realize it's very hard to read. Also in the bottom left of this current slide, every committee has a committee manager that works directly with that committee. All of those contacts are also part of that chart. But like I said, if you don't have access to the chart, please contact me, and I'm happy to put you in touch with the appropriate person from my team that can help you get involved, get on that committee roster, give you any information that you might want regarding a particular committee. So with that, I'm open to any questions. I know you're kind of short on time. So again, if anyone does have some questions even after, please feel free to call me, email me, and I'm happy to help.
Hey, Kerry. Thank you for the session.
Thank you, and thank you for running the slides. Apologies for the technical difficulties.
Yeah.
No problem. You're most welcome, Kerry. Thank you.
Thank you, appreciate it.
Yeah. Dr. Ravi, should we go ahead with the session, parallel session 1?
Yeah, let's go ahead. We are running late. I know people want to take break, but I think let's go ahead.
Yeah. Apologize for the delay. Yeah. Good evening and good morning, members, ladies and gentlemen. Welcome to the day 2 parallel session 1 of Aero Standard Workshop 21. I am Sandeep Pirije, working as specialist engineer at Eaton Aerospace, and I'm joined by Mr. Satish Thokla from MathWorks. It's our pleasure to host this session. I think earlier today we have learned a lot. We learned about SAE ITC standardization activities, understood the role of standardization to improve efficiencies and quality. We looked at UAS activities, standardization roadmap for UAS, and we also recently learned about how to get involved in the aerospace standard development. Now, continuing the theme of safety assessment in UAS, in this session, we'll learn more about the activities of SAE S18, Euro K, WG63 Aircraft System Development and Safety Assessment Committee from Robert Oras. Then Michael Kass will walk us through the activities of SAE E39 Unmanned Aircraft Propulsion Committee. And this session will end learning about standardization of aerospace sector in India from Ravindra Beniwal of Bureau of Indian Standards. Let us start with the session 1. So few words about the first speaker, Robert Oras. He is serving as a chairperson of SAE International S18, Euro K, WG63 Aircraft System Development and Safety Assessment Committee. This committee brings together qualified specialists for the advancement of air safety and to support effective management through the development of technical reports. These reports are key to civil certification of aircraft. Bob has more than 20 years of experience and has held a variety of positions of increasing responsibilities, starting at Cessna Aircraft Company as Flight Control System Design Engineer. He has supported the type certification and system safety assessment of multiple Part 23 and Part 25 aircraft for new and amended type certificates. During his time, he has also achieved Design for Six Sigma Black Belt, patents, published papers, and authored a chapter in World of Civil Aerospace. He is the key interface on these topics to both industry organization and certification authorities at local and policy levels. Please note that this session is a recorded session. We won't be able to have a live Q&A. However, you can type the questions and we'll get back to you. Let us start with the session. Thank you.
Safety lead at Merlin Labs, which is a recent transition for me that happened in mid-August. I am originally from Textron Aviation, the manufacturer of Cessna and Beechcraft products, and I was the engineering process manager for the development of system safety and development assurance processes. I had been at Textron Aviation for 23 years, starting as a flight controls design engineer, moving up to system safety and development assurance over that time. In 2012, I got involved in the S18 Aircraft and System Development and Safety Assessment Committee. Over time, I entered into multiple positions and then eventually was elected the chair of the committee in 2017. Have been the chair ever since. I'm on my third term there. And today we're going to give a presentation on what S18 and its sister organization, Working Group 63, are doing currently and our future work. I'm going to touch on three major topics. First, I'm going to give a familiarization of the S18 and Working Group 63 organizations. I'm going to go into the work that we're currently doing, and then some future topics that have come up that we are looking into work, but we haven't quite defined what the tasks are yet. Now, familiarization of S18 and Working Group 63. This is the S18 charter, which is published on our website, and I will include that link at the end of this presentation. Our charter is to bring together qualified specialists to advance aerospace safety and effective safety management. We also provide a resource to other committees, external organizations, which I'll also point out later in the presentation, just to make sure that we have alignment in our safety processes. So this affects safety assessment, development assurance, and in-service safety assessments. But ultimately, our core objective is to assure that we maintain an inverse relationship between the severity of an aircraft's failure conditions effects and the probability of their occurrence, particularly when we are designing that aircraft. Our sister organization is in EuroK. It's called Working Group 63. Its title is Complex Aircraft Systems, and its objective is similar to ours, where they are trying to provide the industry with guidelines relating to the safety of aircraft systems and equipment for development and in service. We're ultimately working towards the same objectives, and in most cases, we have parallel documents between S18 and Working Group 63 that are either just a slight modification or a repeat of those documents, and I will point that out through the presentation. Again, my name is Bob Roth. I'm at Merlin Labs. S18 has a vice chair, Dave Mergen, who's at Boeing Commercial Airplanes, and our secretary is Mike Norman at General Electric Aviation. Our SAE staff representative is Kevin Byers, who's normally the chief point of contact, especially when you're interested in the committee. Working Group 63 is a European-based organization, and it is led by Chris Lacey from Airbus, and his co-chair and secretary is Julian Chow at Liebherr Aerospace. Generally, S18 and Working Group 63 meets twice a year, though S18 has 4 meetings a year that are quarterly meetings, and we'll touch on that as well. This diagram is from ARP 4754A. It actually highlights the key documents that our committee is focused around, and the other documents that we produce normally are related to them. So ARP 4761 is probably the most famous. It is the safety assessment process, guidelines and methods, and it is closely related to ARP 4754A, which is also related to the electronic hardware development process defined in the RTCA DO254 document and software development lifecycle DO178 from RTCA as well. We also maintain safety assessments of aircraft in commercial service, both for general aviation and commercial carriers. Just to give a high-level overview of the process, this is the highest level we could possibly view it. The blue boxes represent the safety assessment activities, the core activities. What we want to do in safety assessment is determine the safety hazards and their effects, use those safety hazards in combination with the system's architecture to identify requirements to reduce the occurrence of those failure conditions, then verify that those requirements were implemented in the vehicle, ultimately showing that the failure condition was addressed. This is what we show in ARP 4761. Development assurance is the companion process, which now highlighted in the blue boxes is really around the definition of that vehicle and making sure the requirements were implemented. So we start with defining functions and architectures. We take the hazard classification, the safety objectives that come from there, and we assign a level of rigor. How much work do we need to do to assure that these functions are implemented correctly? We increase that rigor based on how critical the function is by the failure conditions. And then we assure that that activity was completed correctly, ultimately leading up us up to show that the failure conditions were addressed by increasing that level of rigor. As I mentioned previously, we have multiple documents that we work on, the chief being ARP 4754A and ARP 4761 shown in the middle of this picture. These two documents have complements in EuroK, Working Group 63. First, ARP 4754A has a document ED79, which is essentially the same document with small modifications. And that will be revised to a revision B. 4761 did not have a complementary EuroK document, and we'll get one with our revision A, which will be identified as ED135. I've highlighted at the top an AIR document. This document is actually an example of how you do development assurance based on ARP 4754A, but it was not included in the ARP when the ARP was published. So that's one activity that we're working on, is to merge that together with ARP 4754A. AIR 7209, the top of the bottom table, is a new document that we've been working on. We've actually had 2 ballots on this document, and we are working towards the third. We'll talk a little bit more in detail on that and all the rest of these documents. As you can see, these other documents don't talk directly to the ARPs above, but they do talk about associations to those processes, and I will go into that Here's an overview of the S18 committee organization and structure. Of course, I'm the chair on top, and our vice chair, Dave Mergen, and secretary, Mike Norman. SAE representative, Kevin Byers, keeps us informed and makes sure that we're doing everything correctly according to SAE rules. Our organization is rather flat. We have a few working groups. On the side, you can see S18A is our very active autonomy working group. It is partnered with the SG1 organization in EuroK, so they actually all meet together in their regular calls. They're producing a document, AIR 7121, which we'll talk about later. That's being sponsored by Corey Laughlin. The S18C in-service documents were recently revised, so that organization is currently dormant. And the S18D, which is the single event effects working group, is also dormant because they recently published as well. So the majority of activity occurring in our organization is directly tied into the top level S18 organization. We're going to talk about these elements through the presentation. As the committee as a whole, we're a rather large committee and a pretty international committee. We have 94 voting members, which means each of these documents will have to get a fair number of votes on those ballots. We have 35 certification authority participants, so they're either voting members or liaisons, and 303 liaisons. This includes the working group's 63 membership. So they have interest, they participate in calls. They're not voting members, but they are engaged in the activity that we do. So it's quite a busy committee. And when we look at where people are coming from, they come from 17 different nations. When we had in-person meetings, and it's been a few years since we've done that, you can hear quite a few languages being spoken. And so we actually orient new attendees to speak slowly and clearly because we conduct the business in English, but that's not everyone's first language. Let's go into the ongoing committee work. One of the big activities that we're working on is revising ARP 4761. This will be its first revision. And its purpose is rather vague because it talks about all the activities going on in the document. But really, it's the 3 aspects of determining the hazards of the aircraft's behavior, define mitigations to ensure those hazards are addressed, and provide methods to show the mitigations are implemented. If you recognize this diagram, or those like it, is the development V, and our process of the safety assessment fits inside that. Just as a reminder, these are the blue boxes that I showed earlier about the safety assessment process, from defining hazards assigning requirements based on those hazards, verifying they were implemented, and then ultimately showing the conditions were addressed. This is the toolbox by which we do that activity. The reason we're revising ARP 4761 is because there was a revision of 4754, which came out in 2010. ARP 4754A also talks about the safety assessment process, but only in relation to its own processes. The diagram on the left-hand side is from 4754A, and the white boxes on the left-hand side of Figure 7 there are actually describing the safety assessment process, except that it added processes that were not described in the safety assessment process document. The PASA, Preliminary Aircraft Safety Assessment, on the top, and the ASA, the Aircraft Safety Assessment, on the bottom. The introduction of these concepts really introduced a bit of confusion and a lot of discussion in the industry, because the document, which should have described how these processes are engaged or implemented, didn't describe them at all. So we need to go back and make sure that we had an effective description of those documents. But this also affected every other document that those two documents touch. So the inputs and outputs to a PASA, Preliminary Aircraft Safety Assessment, will affect a functional hazard assessment, the FHA, the system functional hazard assessment, a preliminary system safety assessment. So ultimately, the entire document of ARP 4761 is being modified to address this change, and also to talk about this concept of functional development assurance level, which was a significant change in ARP 4754A and needed to be talked about in 4761. As you can see in the diagram on the right-hand side, they put the concept of the FDEL and IDEL assignment process wholly inside the PSSA and PASA, and this was not discussed in 4761. So this is certainly something that we need to make sure we address. This has been the bulk of the work that we've been doing in 4761A. We've also wanted to keep up to date with processes going on outside of those changes, and so we are also adding new appendices in 4761. One for model-based safety assessment. There is a new appendix there. Cascading effects analysis, a new appendix is also being added. These two are also being discussed in the contiguous example, which is being updated in 4761 revision A. We've also added some other topics. In addition, the master minimum equipment list has been added as a discussion, and in-service safety assessments has been more directly addressed in the new revisions. We had a lot going on in this revision. It's taken us quite a long time to get this revision out. We plan a very near-term ballot date of October 25th. So we're looking forward to getting that out and published very soon. Related to 4761A is actually 4754 Revision B. As I noted earlier, 4761 Revision A came out without addressing the safety assessment process. So we don't want to make that mistake again. And so we're doing a parallel release of these two documents to make sure they're synced up. 4754 talks about the planning and development assurance, means of verifying and validating requirements based on the rigor of the hazards that they address, and demonstrating that that planning was accomplished. Again, this is a diagram I showed earlier. There's a number of changes that we're doing. I'll talk to a few of these in a little more detail. We are aligning, of course, to the scope of 4761A. As I mentioned, we don't want to get out of sync with this revision. We want to make sure the content is aligned. We've improved development assurance planning discussion, improved our discussion of validation and verification, aligned our modification section with the other ARPs. We've also changed the objectives, but in how we describe them. And we're also integrating AIR 6110, as I mentioned previously, as an appendix for 4754B. I'm going to talk to these four topics because they are actually the most detailed element that we're changing and pretty significant beyond the lining up with 4761A. So if you're familiar with 4754A, which describes development assurance processes, it talks about development planning, and it talks about planning throughout the document, but it never really addressed as a whole what a development assurance plan is and how it might be different from development planning. We've also seen in the industry that regulators have asked for a development assurance plan, which was never mentioned in the ARP. And so we've rethought how the planning is described in ARP 4754 Revision B. We've created a dedicated section for development assurance planning to bring together all of these thoughts to solve that problem. What does it mean to plan for development assurance? We've also more deeply ingrained the certification authority coordination planning. This used to be at the end of the document, which really de-emphasized the certification aspects. We brought it to the forefront and put it on top, engaged in the planning aspect, which we thought was critical to understanding how we approach development assurance. The next topic is aligning modifications with other sections of the ARP. In the previous revision, ARP 4754A identified Section 6 as a high-level approach to dealing with modifications, almost to the level of a change product rule description. We wanted to tie this more closely into the sections of ARP 4754 and actually call out those sections. Therefore, we created a functional-based approach. Our processes are based on function definition. This allowed us to come up with a way to tie together Section 6 with the rest of the concepts, come up with a better support of explaining how modifications work and how that relates to the development assurance process. Less prescriptive objectives, ARP 4754A sometimes just describe tasks, conduct, or the PSSA is performed, or the SSA is performed. But an objective should be, why are we doing that activity? And so we've generalized the wording around these objectives to make it more clear in case of other people wanted to try to approach it with a different process. We've also cleaned up the section references. There were a lot of redundant section references that made a complex relationship with the main body. We cleaned this up to make a clear association between the objective and the parts of the document which actually describe how those objectives are met. AR 6110 has been a standalone document and in a lot of cases has been ignored. This is actually equivalent to what ARP 4761 has. ARP 4761 includes a contiguous example of how the process is conducted, and it is an appendix to that document. ARP 4754A, which describes development assurance, didn't have that as part of the document. It was published later just based on deadlines. We thought this was a mistake, and we wanted to bring this into the ARP 4754B. So not only are we bringing this document into ARP 4754B where it belongs, but we're actually aligning both processes in this example. So you can see the flow of information between the two processes as you read both examples. I think this will be significantly beneficial to readers, especially new readers of these documents. There's been a lot of work going on with this document as well, but we hope to ballot this near mid to end of November based on how we do with ARP 4761 as well. This way we can have both of these documents out in short order, which will allow us to see how all these processes fit together better. A new document that we are going to ballot is AIR 7209. This is the third ballot. We've gone through quite a few reforms of the document, but really it's a higher level discussion around ARP 4754 and its objectives and what the actual intent of these things are. So this higher level view is to help with what we call advanced air mobility platforms or new entrants who want to understand development assurance and apply it and may have different ideas of how to apply this. It's more of a discussion AIR at this point, but it depends on how people read and view this document. We are planning to go to ballot on September 20th. So by the time you see this recording, hopefully we will have this already in out. AIR 7121, as I mentioned, is being produced by the S18A Autonomy Working Group. This document is really to identify gaps within the processes that SAE S18 committee produces. So particularly ARP 4754 and ARP 4761. some key topics that we address in this document are how UAS ConOps interact with the ARP processes, operational risk assessment, which is used in UAS, and how its interaction fits within the ARP, qualitative and quantitative criteria around failure conditions relative to these advanced air mobility platforms and how those might be addressed, the metrics, safety analysis, and other aspects of these processes, which this is only a sample of. There's a number of these activities. They're currently working on a draft, so we do not have a date set. The tools, AIR 6276 is one that's been in work for a while, but has been put aside because of our focus on the ARP. We have a lot of specialists that work both on those ARPs and this tool set. This is to explain how tools are used in the role to support the safety assessment process and development assurance process. It gives modeling considerations of that system development process and the aspects of those modeling considerations, and it'll give some case studies relative to a control system and an avionics network. This has been recently picked up again, so we don't have a draft date set for ballot. Another new work that we are working on is AIR 6913. This is sponsored by John Thomas from MIT, and it's an explanation of how the system theory process analysis is applied in the context of safety assessment. Safety assessment, of course, identifies hazards, but also provides probabilities, whereas the STPA process only talks really to hazards. However, there's a lot of benefits STPA provides that we know are gaps in the 4761A process, such as human factors and human-machine interface. So we can support this activity by finding a solution that integrates both processes, and that's the objective of 6913, and it's still a draft document with no date set yet. Looking towards the future. Working with the FAA, we've identified some key gaps that we're trying to fill, specifically around human factors. There used to be a bright line between human factors and the safety assessment process, but the 737 MAX investigation clearly identified that this is a deficiency that needs to be filled. And so we are working both with the regulators as well as a number of SAE organizations shown to the right of the slide here to identify the human tasks that need to and how they're addressed in the safety assessment process. The little diagram I have on the bottom is kind of the aspects in which a function is considered through the process: system behaviors, mechanism definition, but also those human tasks, the flight manual procedures and maintenance manual procedures that need to be done. So we're trying to fill that gap of that highlighted element and better define how that works. A new generic errors team was put together to discuss the additional mitigations that are sometimes requested by regulators and how we can address them. The survey was performed on the S18 committee, and we had 160 respondents. Right now, we're still trying to define the problem, not solve it, to figure out where there might be solutions already either in existence or where there might be gaps that need to be filled. S18 in general applies a liaison process to a number of organizations. These are the committees that we have active organizations in, liaisons with. And so we are normally coordinating with these, and they are part of our quarterly meeting reviews where we update on those liaison activities. Speaking of our quarterlies, we will normally update all this existing work and external coordination every quarterly meeting. Our new work is proposed in those quarterly meetings, as well as our regular work, of course, is moved forward. Our next meeting is going to be the week of October 18th, and this will be a virtual meeting. So anybody who would like to attend can actually go attend. The information is on the website. We feel free to dial in. The website link is provided below. The QR code also goes to that site. Feel free to reach out to me or to our SAE representative to find out more about the S18 committee. Thank you for the opportunity to present. name is Ravirajan. I am the system safety lead at Merlin Labs, which is a recent transition from me that happened in mid-August. I am originally from Textron Aviation, the manufacturer of aircraft products, and I was the engineering process manager for the development of system safety and development assurance processes. I have been at Textron Aviation for 23 years, starting as a flight controls design engineer, moving up to system safety and development assurance over that time. In 2012, I got involved in the S18 aircraft and system development and safety assessment.
SAE office. Yeah.
Yeah, thank you. I think we have a couple of questions. What we'll do is we'll take these questions with the speaker and then we'll get back to you. So we'll move on to the next session. This session is taken by Michael Cass. This is about E39 Unmanned Aircraft Propulsion Committee and how they are helping to develop standards and recommended practices for the UAV engines. Few words about Michael Cass. Michael Cass is a distinguished engineer in Engines Research Group at Oak Ridge National Laboratory. He has over 20 years of experience in the field of dynamometer-based engine testing, combustion, emissions research, engine materials, and alternative fuels, including small reciprocating engines used in UAV applications. Mr. Cass also holds a PhD in metallurgical engineering from University of Tennessee. He is a fellow of SAE International and is the current committee chair for E39, which is dedicated to developing standards and recommended practices for UAV engines. Please do note that this also is a recorded session, and similar to what we said earlier, we would be getting back with the answers for whatever questions you type in the chat. Thank you. Office, can we start with the session?
Welcome. My name is Mike Cass. I'm the current chair for the E39 Committee on Unmanned Aircraft Propulsion. I would like to thank SAE India for inviting me to speak about our activities. And I'd also like to thank my committee members who have been very active in the recommended practices that we've put forward, and my coworkers at work and elsewhere that have supported me in this role. I'm sorry that we're not here in person, but look forward to doing this virtually. So by way of introductions, I'd like to begin by stating up front, we're actually a fairly small group. We're probably one of the smaller committees, even though we're new. We've had the interest kind of waxes and wanes. I think it's starting to rise here lately. But in addition to myself as the chair, I'd also like to mention the steering committee members, which consist of Dr. Jeff Cathcart of Orbital Corporation, Dr. Ravirajan, who is a consultant that also works with the University of Connecticut, and Jeff Ratcliffe, who is the Chief Technical Officer for Northwest UAV Propulsion Systems. We also receive considerable support input from Mark D'Angelo over at SAE and from Nicole Mattern, and I would like to acknowledge their valuable contributions in helping moving the committee forward and helping us moving towards getting a recommended practice or standard. Okay, so this slide here is a bit noisy, but I think it's important because it shows that there's a lot going on right now in the field of transportation and communications and the melding of both of those two areas of technologies. For the UAVs, we see ourselves, especially for the small ones, more along the roles of package delivery, surveillance opportunities and inspections, and then on communications as well. But it really is just one part of a bigger network, and one that we're seeing a lot of development, a lot of new technologies are now coming to the front, new transportation technologies. And as such, there's also very much, it drives the need for increased standardization as well. So there's going to be a really kind of a flurry of activities in this whole space, and we're a small part of it. And we certainly welcome anybody that would like to help participate on this too. It's going to be exciting. Thank you. Okay, so we're really one of many committees devoted to standards within the SAE International Aerospace Standards Development Program. There's quite a few. Our particular committee is over here into the Aerospace Propulsion Systems group. And I'd like to point out that there are other committees besides ourselves that are devoted towards aircraft propulsion and other aspects, and that we do, in fact, communicate and liaison with these other committees. We receive input, and then we also give an overview of where we are and what are our activities as well. And one of the reasons is to see if there's any opportunities to maybe co-sponsor a standard or recommended practice. But the point I want to take away is that there is quite a bit of communication and relationships that are going on between the committees. Very frequently, some of the committee members that are in the E39 are also involved in the E40 and the other committees as well. So there's a lot of interrelationship between all of this. So now I'd like to talk a little bit about some of the background that really kind of led to us forming the E39 committee, one that is focused on small UAS or UAV propulsion. The primary driver is that when we think of UAVs, they really employ propulsion systems, even if they're all engine systems, that differ significantly from one another based on manufacturer, based on operation, whether they're rotary or whether they're a reciprocating engine, 2-stroke or 4-stroke. As a result, you've got a lot of different options out there for propulsion, but how do you evaluate those on a normalized value? That was a driver for this committee and the need for a standard. One, to ensure safety that will allow unmanned aircraft to reach the full operation potential. And the scope, as we've defined it, really, we've got it broken down into chemical propulsion, electrical propulsion systems. But let's really focus on chemical propulsion, because we're really talking about what we consider kind of our conventional reciprocating engines, 2-strokes, 4-strokes, and then rotary engines as well. And that's really been our basis. And our committee members have really been focused primarily, or come from industry that primarily provides reciprocating engines. Though we do have involvement in precipitation from time to time from the turbine side of things as well. So the benefits really to the UAS community and industry really are as follows. One is to access a wealth of UAV and propulsion knowledge, which we feel is really fairly represented in our group and our committee. Secondly, we do extensive networking with industry colleagues, the regulators. We have the FAA regularly participating on our monthly meetings, and research academia community as well is engaged in really a very open forum. One of our goals is to establish a uniform set of test specifications and to understand well-defined categories and systems types as it pertains to the propulsion system. And we also seek to build upon industry best practices and their specifications. And really, there's just opportunities through the committee to really prioritize industry standardization needs, which is really the primary driver for the committee. I'd like to continue on with the historical perspective of UAS propulsion. When we think about UASs today, and we think about development and we think about technologies, a lot of times our emphasis has really been primarily on the sensors or the payloads that have really been driven on these systems, primarily by the military needs or for some sophisticated surveillance needs. So there are really some conflicts, unfortunately, or maybe conflicts isn't really a good word, but maybe there's been kind of a lopsided view of technology development in UAVs, because all the advances that were done with controls and sensors and cameras really surpassed that for engine development, which really kind of got left behind. Now, there's a misconception among many in the UAV community or among the community in general that reciprocating engines are really just an off-the-shelf technology. They're mature. There really doesn't need to be any development. We just grab something off the shelf and put it in the end of engine, and that's not quite how things work. Unfortunately, compared to the large high-tech, or I should say, even the larger engine companies, the automotive or generator or the heavy-duty side of things, really small UAS engine manufacturers are really, the companies are much smaller, much less influential, and they do not necessarily have the capital expenditures to that they can then devote to the the research side of their companies. The other thing too, it's a very highly competitive field. As an example, when we think about the propulsion systems for UASs, they often represent less than 10% of the total cost, as compared to, say, the car I've got in the lower left-hand corner, where it's really the engine or the propulsion system is around 10 to 15% of the cost versus really much less than that, if not a fraction, for a lot of the UAVs, which is shown here on the right. Even the engine cost for an airplane is still a higher percentage of the overall cost compared to UAVs. I'd now like to say that everything is really starting to change. As the power and energy demands of UAVs increase, there is a heightened interest now in UAS propulsion technologies. We all know that the number of UASs or UAVs, especially the small ones, since they are less regulated, are poised for high growth. As a result, the operational costs and their reduction are starting to be emphasized now. Fuel flexibility is desired, improved efficiency is desired, and the power demands for UASs are increasing, and those power demands are brought about by the desire to carry heavier payloads, increased CPU and image processing, adding on, and the number of spectrometers and instruments, and then also adding on more sophistication regarding the surveillance and data collection. All of that is driving the power demands. They are driving improved efficiency, and all of that translates to improved engines, improved propulsion. I would argue that the engine or the propulsion system is really the most critical component of the UAS. It is the primary source of the thermal and acoustic signature of the UAS. It provides all of the thrust, whether it be a reciprocating engine, a turbine, a rotary, or an electric motor that is battery powered. It powers the sensors and all the instruments, as I alluded to in the previous slide. It by itself defines the range and the payload requirements. It sets the environmental limits, and it frequently sets the total system durability, meaning that your UAS only stays aloft as long as the engine is still operating. And it is very often the engine or the propulsion system that determines whether the UAS crashes or doesn't. Now, the engine is only one component of a much larger system when we think of the propulsion system. And it has always been cognizant in the E39 committee that when we are developing standards or recommended practices and discussing these, that we need to consider this not just from the engine or the motor perspective, but also from all the supporting systems as well. And that includes the propeller linkage. It includes the fuel storage and delivery system and the fuel pumps and whether there's an injection system or injector or not. It includes the fuel tank as well, and whether that's pressurized or left under ambient conditions. The other system that is important too is the lubricating system on many engines. A lot of, even now that we're starting to see even on the smaller UAVs, a separate lubricating system that needs to be considered when developing standards and recommended practices. We also need to look at the parasitic systems, such as the electrical conversion systems, the alternators, whatever voltage regulators, and if there's any battery storage on board. And then also the noise suppression as well. These are all very important components of a much larger system. I haven't even begun to even talk about, boosted systems as well, but there are a number of directions we can go into. All of them need to be considered. So this slide really kind of gives you a snapshot of where we are, though in all honesty, it's probably been dated by about 5 years back, and I have probably and needs to be updated. When we look at the breakdown of propulsion systems and types by UAS manufacturers in the United States, anyways, we see that obviously electric motors are the most common. We noticed that 6 manufacturers are stating that they, at that time, that they're going to making heavy fuel versions of reciprocating engines. So this is something that run off a distillate fuel instead of also a gasoline or a light alcohol type fuel. The other thing is that the UAS size really kind of dictates the propulsion requirements. When we're talking about micro UASs, those that are less than 4.5 pounds, for all practical purposes, those are either electric or single cylinder glow assist engines, otherwise known as the hobby engines that we're all familiar with. When we start talking about smaller UASs, which are defined as being under 55 pounds or 25 kgs, these are predominantly single cylinder engines. In some cases, they're also electric motor driven, but a lot of them are actually single cylinder engines just because of the energy density and power density requirements. The medium-sized UASs are virtually all 2-cylinder, 2-stroke engines or rotary engines. Then, of course, the larger UAS systems are multi-cylinder reciprocating engines or rotary engines or turbines. As little as 5 years ago, only a few UAS manufacturers advertise hybrid systems. Now the majority do. So this is kind of an interesting reversal from what we're seeing in the automotive companies, where they're moving from engine technologies to more electrical power operated vehicles. In the UAS community, we see them going away from being all battery electric to having a hybrid system with a reciprocating engine, just to advance the power and range requirements of the UAS. Now, we feel that hydrocarbon fueled engines should be an immediate focus. There are several reasons for this. One, hydrocarbon fuels have 45 times the energy density of the best lithium batteries. Reciprocating engines are relatively inexpensive compared to fuel cells and even some of the higher expensive battery technologies that are out there. Now, they have low efficiencies, say around 10%. Therefore, even marginal improvements will have a significant effect on reducing the fuel volume weight or increasing flight duration and power. Engines are much more adaptable to logistics fuel utilization than other technologies, such as fuel cells, which really are not adaptable at all. Piston and rotary engines are proven technologies for small UAS-sized applications. And we also need to consider not just the engine itself, but also the conversion to electrical power storage, especially at small scale, needs to be considered and will be an area that will have to be developed better and will be looked at more, and will therefore likely involve some recommended practices and standards as well. So there are many established technologies that are out there for efficiency and power improvements to engines. They include, we look over here on the right with the tree of low-hanging fruit. Over the years, the engine, at least automotive engines and other engines, have been improved through advances in spark timing, reduction in friction, the advancement of dilute combustion, better engine materials, and better fuel injection have all led to efficiency and power improvements in today's engines. Now, in order to take full advantage of these technologies, it's really going to be necessary to perform controlled experimental evaluations. The primary tool for that is to use an engine dynamometer, shown here in the diagram in the lower left. And this is what I'm going to really talk about here in the next several slides. So the engine-based dynamometer really is the primary means of advancing engine development. It is the primary research tool. It is used widely in the automotive industry. It is used widely in the development of generators and other means of transportation or power generation that involves a hydrocarbon fuel. The reason being is, one, it can manipulate speed and load independently. You can determine the brake-specific performance, which is normalized for power, to allow performance comparison between engine types. That is very important, and that is one of the main drivers for developing the standards or the recommended practices in this space. It is also used for the accurate characterization of combustion, since you can manipulate both the speed and load independently. Now, it has a disadvantage in the fact that dynamometer-based testing is expensive, requires sophisticated coupling. It also does not replicate the altitude unless it's placed inside an environmental chamber. Therefore, you need correction factors, which are also to be included in any standards and recommended practices. But in summary, virtually all engine-based standards really center on dynamometer-based testing protocols, which is something that we are actively doing in this committee. So, in short, power measurement standards are really needed. They're not out there today for small UASs, especially for those systems that have been developed for the hobby community. There are a number of different methods out there for power measurement, which vary widely. That needs to be consistent. Correction factors also need to be developed that are reliable and useful. Preconditioning is often overlooked as well, and that's something that needs to be considered, and on and on. But I just want to conclude that it is very, very important, to get a standard or to evaluate your engines according to a set standard in order to do a fair evaluation on them. That's the primary need for this standard committee and for the work that we're doing. The committee recently published a recommended practice, number 6971, to deal with engine test protocols for small UASs. Now, we based our recommended practice on standards that have been developed for the larger automotive scale engines, and then made several caveats to those, or we tailored them to be more relevant and specific to the small UAS engines out there. In general, one of the concerns was the fact that you can see in the table on the right, as you reduce the torque, meaning the power or size of the engine, the accuracy also becomes much more challenging to measure down at the levels, which you would see for some of the larger sized engines, larger torque engines. Therefore, if your equipment is only able to measure up at plus or minus 5%, going down to 0.5% in a standard really just is not feasible or relevant. So we expanded the accuracy levels. There was some consistency in terminology that needed to be defined. For example, simple terms such as engine and horsepower mean different things to different communities. The standard goes ahead and defines those in a precise way. For those who are interested, we have I'd call an introductory overview of the committee and what our goals are, and I would refer you to the WP-0009 to read a little bit further more on UAV applications and propulsion technologies drive to the development of UAV propulsion standards. Since the publication of the recommended practice, we've now kind of convened among ourselves to decide on a new project proposal. And the consensus among the group is really along the lines that we really need a new endurance test engine standard, which is we feel is really just kind of a logical extension to the recommended practice for testing the engine durability. And the endurance test principles that we'd like to include in this standard and recommended practice that we're going to work on is going to be, a test plan that would be written and disclosed that the user community could use, define critical dimensions, determine how to incorporate engine taxiing in a series of operational tests, that might include conditions that are beyond typical flight requirements, looking at the parasitic or other loads associated in the engine, including the electrical subsystems. We'd like to put together a test suite that is suitable to use as a basis for projecting the time between overhauls, which is a critical feature, especially when you're talking about UAVs for military applications. We'd like to provide just enough information to justify or project a preventative maintenance schedule. To continue with that, the schedule maintenance would also be determined as the maximum allowable intervals along with those. We'd like to have enough flexibility to perform without having to take exemptions, and then a thorough understanding and explanation of all the repairs and scheduled maintenance. Ideally, just to conclude the last three bullets, we're going to use FAR 3355 as really kind of the starting point for developing this durability standard. And we would like to, solicit any input and participation from anybody who might be listening to me. If you're willing to think this is an area that you might be interested in, please let us know, and we'd like to include you in the committee. That concludes my presentation today. Thank you.
Yep. Thank you. It was a great session learning about the critical component engines for UAVs. We'll start with the next session. The next session is from Ravindra Beniwal on standardization of aerospace sector in India. Few words about BIS. Most of us know Bureau of Indian Standards is national standard body of India established under BIS Act 2016 for harmonious development of activities of standardization, marking, quality certification. BIS has been providing traceable, tangible benefits to the national economy in several ways through standardization, certification, and testing. Talking about Ravindra Beniwal, he is Scientist C and presently working with Bureau of Indian Standards, Government of India. He has graduated in Mechanical Engineering from Rajasthan Technical University, Kota. He has experience of more than 5 years working in BIS, including the standard formulation activity, product certification activity, activities related to enforcement and consumer affairs, and dealing with various subjects related to mechanical, civil, transport, engineering, and medical disciplines. At present, he is working as member secretary to technical committees TED 14, 16, 24, 28, and 31, and in license with international technical committees ISO TC20, ISO TC204, ISO TC122, and ISO TC104 and TC192. He is avid reader and has also authored a number of blogs and articles which have been published in various print media and online forums. Over to you, Ravindra. Thank you.
Thank you, sir. I hope I am audible now.
Yes, you are audible and we can see the presentation.
Thank you, sir. Thank you very much. Hello, everyone, and greetings of the day. This is Ravindra Beniwal, Scientist C from Bureau of Indian Standards, BIS. Bureau of Indian Standards is the national standards body of India, which was established under the BIS Act 1986 and now revised as BIS Act 2016. It is a statutory body under the Ministry of Consumer Affairs, Food and Public Distribution, Government of India, and it promotes the harmonious development of the activities of standardization, quality certification of the goods, and attending to the connected matters in the country. Headquarters of BIS is in New Delhi. We have a connected system of 9 laboratories, 33 branch offices, and 260 recognized laboratories for various products. As my previous speakers has also emphasized, and you all are very aware that importance of standards in the aerospace sector keep the stringent requirements of aerospace material with regard to performance, quality, reliability, natural and induced environmental stress. It enhances the interoperability of the equipment. It ensures the supply of unambiguous technical statements for reference or contractual purposes. Standardization also reduces the risk of dependence on specific vendor, and it provides the consistent level of equipment safety and conformity to regulations. also station promotes the Indian efficiency through variety control. If we talk about the quality ecosystem in India, through the Director General of Observation and the Directorate of Standardization under Department of Defense Production, standardization is done through the entry control and variety reduction, and various joint service specifications have been made. Adoption of Indian standards formulated by Bureau of Indian Standards for material, equipment, test method, etc., and preference to making departmental specification to avoid duplicity and exercise economy of the effort. And we have active participations by Defense Research and Development Organization, DRDO, Hindustan Aeronautics Limited, National Aerospace Laboratories, Indian Space Research Organization, technical committees for the formulation of Indian standards and their eventual adoption. The Bureau is supporting the government initiatives and the National Civil Aviation Policy of India through the simplified and transparent system of standardization, testing, and certification with greater use of technology without compromising on safety and security, and also enhancing ease of doing business through simplified procedures and e-governance. Entire aviation sector through standardization in a harmonized manner, covering cargo, general aviation, aerospace manufacturing, and skill development, and also is supposed to MSMEs, and reduction in licensing fee structure. Now, if we talk about the standards formulation process at BIS, BIS follows the 6 principles as per the WTO TBT agreement, that is World Trade Organization Technical Barrier to Trade Agreement. These principles are transparency, openness, impartiality and consensus, effectiveness and relevance, coherence, and development dimension. The structure of BIS standard formulation is through the governing councils. After that, it comes the Standardization Advisory Committee. And beneath them are division councils and various sectional committees of the Bureau, which formulate the subcommittees or panels under them. At BIS, standards are developed by the relevant technical committees. Technical committees of BIS comprise representatives of various stakeholder interests, such as industry, consumer, technologists, scientists, professionals, policymakers, and regulators. More than 10,000 experts are the member of various BIS technical committees, which are distributed among 15 different division councils of various engineering sectors. And standards are developed keeping in view the national interests and after taking account all the significant viewpoints through a process of consultation. Decision in BIS technical committees are not reached by voting, and it is reached through consensus. BIS being a signatory to the WTO TBT Code of Good Practice for the preparation, adoption, and application of standards, has also accordingly aligned its standards formulation procedure. If we talk about the BIS committees in aerospace sector, the parent committee is the Air and Space Vehicles, Air Cargo, Related Systems, and National Committees, Transport Department, TD. The Science Committee is formed for the standardization in the area of unmanned aerial vehicles, that is 14.1. And we have also panel on drones for agricultural purposes, aerospace quality management systems, and fasteners for aerospace. Important standards formulated by BIS in aerospace sector includes various standards for aircraft electrical equipment, ground equipment and fasteners, aerospace quality management systems, gas turbine acceptance test, various environmental tests for aircraft equipment, ATF, ultrasonic pulse echo testing, and the aircraft tire tube and valves. In the emerging areas of UAV, we have formulated standards on general requirements of remote pilot aircraft systems, standards on UAVs testing and certification, and cybersecurity. The process of formulation of standards for drones for military surveillance, smart farming and civil uses are also undertaken by the committee. A standard on UAV management is also at the formulation level. BIS is one of the founding members of ISO. It is a signatory to the WTO Agreement on Technical Barriers to the Trade, TBT agreement, which was signed in 1995. As the national standards body of India, BIS participates in international standardization activities and projects India's interests and viewpoints during various stages of the development of international standards, and harmonization of various Indian standards in aerospace sector with international standards is also being done to facilitate trade and reduce the duplicity of efforts. BIS is actively involved in the working of ISO TC20, that is on air and space vehicles, and its subcommittee ISO TC20 SC16 on UAVs. Key challenges for shaping the future includes building a robust quality infrastructure and self-attitude for self-reliance, and the support is expected from stakeholders, industry, academia, and government to enhance participation in standards formulation activity. There is a need to fuel trust, transparency, and stability in the activity, and to realize the potential of innovation and startups. On other hand, there is also a need to invest in R&D for alternative propulsion, commercial aircrafts, and urban air vehicles for logistics, medical surveying, security, and transport sector. In the process of standard formulation activity of BIS, you can get involved and access all the standards for free of cost, including all the standards formulated on the vehicles. Become a member of the technical committee, and you can also provide your comments on standards and the formulations. BIS has also a product certification scheme, and as per the quality control orders issued by Government of India, there are more than 250 products which are under the mandatory certification of BIS. And for any queries, you can anytime mail me on ravindra.beniwal@bis.gov.in. And if you need any standards or standards which are under formulation, just write a mail to me, and I'm happy to answer all the queries. Thank you, everyone, and good day.
Yeah, thank you, Ravindra. That was a great session on understanding how we are doing on Indian standards. Dr. Ravi, how are we doing on the other session?
We are good. Most probably, do we have any questions for Ravindra? Probably.
Yes. We have some time.
I have one question, sir.
Sure.
Yeah, I'm
Please
George.
go ahead.
I'm George from ABIS, and I work specifically on materials and process, and I work as a fastener specialist. So if you want to be a part of this technical standardization committee, what is the procedure, sir?
Sir, you can just write a mail to me, and I will send you the procedure, sir. You can just send your CV, and we place it before the committee. And if the committee agrees, then anyone can become a member of the technical committee, sir. Just write a mail to me on ravindra.beniwal@bis.gov.in. I am also writing my mail address in the chat box.
Sure, sir. Thanks a lot. It really helps. Yep.
Ravindra, we don't have any questions on the chat box. Anyone else has any more questions? They can directly talk. We have some time.
So only one more request, Ravindra, is if you can share the presentation, whatever is shareable, because many presenters are looking for it. Look forward.
Yes, sir. Sure. I'll share the presentation on your mail ID, sir.
Sure. Thank you. Okay, no, I think that's a pretty good presentation, Ravindra. Thank you. In fact, there are a few people from the international community here. Ritesh is there, who is an FAA representative. So you want to reach out to you. And we are also encouraging this kind of collaboration between India and the US, or India and the international. So we look forward for the wonderful support going forward, Ravindra.
Of course, sir. We are also looking for the collaboration, and any support needed is always provided from us, sir. All the collaboration is welcome from BI's end.
Thank you. Thank you. I think we are done on the parallel session. I think people are joining in. Hassan, are you there?
Yes, sir.
Yeah. Is it the parallel session too? Is it done now?
Yeah, it's going on, sir. I think the question answer is going on. Almost is done, sir.
Okay, sure. Then we'll wait for a few more minutes.
I think the questions which have been typed for the speakers who are not online, we have noted them and we'll get back with the answers to all.
Right. And yesterday's questions as well, we have I summarized all of them. We are going to send them shortly to all the presenters. Once it is done, we will reach out to you. And if anybody is interested in any of these standard committees, please feel free to send out a mail. In fact, we will be sending shortly a feedback form. In the feedback form also, you can represent if you want to be part of any of these technical committees, you can let us know so that we can take it forward further. And I assure you, it's a great learning working with these technical committees. In fact, SAE India conducted IHIM workshop a few years back. And during that time, Ravirajan conducted the HM1 technical committee meeting in Bangalore. That is when I got introduced to the committee. I attended the first meeting. And I found it very interesting because there are a lot of like-minded people, technically knowledgeable people working for these standards. So it's always pleasure to work under each of those individuals, learn from them, and contribute back to the industry. Okay, so please feel free if you want to be part of the technical committees. Initially, you will be able to, you'll be understanding what and how the committee works, and slowly you'll learn and you'll start contributing it.
Yes, Dr. Ravi, I think that is a great opportunity for all of us. I think this workshop has given us the great learning, and the way we have been organized, it has been organized. It will tell everyone what needs to be done, how it needs to be done. It is a great opportunity.
Probably if we have some few more minutes, our SAE office can run the short video what you ran yesterday on the SAE International Standards for the benefit of others who have joined today.
Sure, sir. So this is playing Aerocon 2022 also.
Can we start the closing session?
AeroCon is the flagship biennial premier international conference organized by SAE India Aerospace Forum and supported by SAE International. AeroCon 2022 is planned to be held in Bangalore, India on 2nd and 3rd of June, 2022. Technology has always been on the forefront for aerospace industry. It incubated, nurtured and matured many advanced technologies, from composites to advanced sensors to integrated vehicle health management. While globally the aerospace and defense industry has been rapidly advancing with new technologies and artificial intelligence, the Indian government is also actively promoting indigenization with cutting-edge technologies by manufacturing them in the country under Make in India and Atmanirbhar Bharat initiatives. AeroCon 2022 will provide the much-needed platform in India for industry practitioners, academicians, researchers and students to actively exchange ideas, information and opinions, share their research findings and experiences in aerospace engineering. The theme of the conference is Autonomous Airborne Systems, Trends, Challenges, and Opportunities. Various special topics of interest have been identified for this conference, including blended hybrid wing body designs, electric mobility, artificial intelligence, machine learning, and digital twins, being at the cutting edge of groundbreaking aerospace technologies. The conference program is planned to have many plenary sessions from international experts, paper presentations, panel discussions and tutorials, spanning the aviation, space systems, aeronautics, airborne defense systems, unmanned aerial systems and urban air mobility. Please visit the conference website at www.saeindia.org/aerocon2022 to know more it. Submit your papers and presentations for this conference, network with your peers and experts in the aerospace engineering community, and be in the forefront of aerospace technologies.
Hi everyone, how are you all doing? So, we come to the end of Aero Standards workshop. 2 days, 23 speakers, 4 parallel sessions. Wow, knowledge-packed, very informative sessions. Hope you all gained some valuable insights into SAE standards and how to be part of these committees as well. So with this, we really hope you all sort of have got all the information that is required for you to be sort of part of these standard committees. With this, like I said, we come to the end of the Aero Standards Committee workshop. On behalf of SAE India Aerospace Forum, I would like to express a deep sense of appreciation for all our esteemed speakers. A big thanks to all the delegates for their presence in making this event a great success. There was huge participation, a lot of questions back and forth. So thank you for making this event a grand success. Also, we would like to thank all the Aerospace Forum members, organizing committee, and SAE India team, the back-end team which has been working tirelessly over the last few weeks to make this event a grand success. So thanks SAE India team. Thank you all. With this, we plan to sign off now. Thank you.
Thank you.
Thank you. Thanks a lot.
Thank you all.
Thank you all.
Thank you all. Take care.
Thank you, sir. Thank you all.
Request all the SAE India office, SAE India aerospace members and organizing committee members to stay back, and or request all the participants and speakers to log off.
Yes, sir. Now we have more. Yeah.
Okay.
Okay, don't want to hold back everybody. I guess, some of you have calls starting. So, hey, first of all, it was a great two-day event. I really appreciate and thank all of you for all your efforts. I think Dr. Ravi, I think you really did, a significant part of the work to make sure, we have all the speakers lined up. It was a lot of work over the last, 2 to 3 months. So fantastic job, I think. And Hassan and team from SAE India office, Hassan, Vijay, Suraj, Aisha, Did a great job. Thank you so much. So we kind of ended on time, which is good. Of course, the first session, Ritesh, we should have actually, I do not know why we didn't, stop him. This is a big lesson learned actually, because he threw the whole thing out of, gear actually. So we
Right.
should be ruthless. Okay. And the moment we know he's come with 34 slides, we should start telling him that, boss, we have only 20 minutes. You knew he had 34 slides. Nobody comes for a presentation for 20-minute talk with 34 slides. 20-minute talk, 10 slides. That's the game plan. Anyway, so let's be careful going forward. Yeah. Otherwise, it's a great session.
Thank you. Thanks, Ravi. It was a great session. It was good. A lot of good people came forward to deliver that. And, they are very, very busy people. In spite of that, they came forward and then session. Thank you. Wonderful anchoring. Satish, both Satish, Sandeep, Sripati, great coordination among all of you.
I think, yeah, the overall, yeah.
Krupal,
Sorry.
Dinesh.
Quite challenging to, manage two sessions, right? You don't know what's
Yeah.
happening. You know what's
No,
happening.
actually, Ravi, there was some confusion. I don't know if any of you got to know that. I
Ah.
was actually attending in track session 1.
Ah.
Sripati is there. He messaged me saying join track session 2 at 6:15. I'm like, the session is at 6:50. I join and there are 25 people already, and Bill Billman is already there.
Oh my gosh.
I'm like, okay, I thought maybe there is a change of schedule and I'm not up to date. I was like, man, how many emails do I miss? So a lot of the times this Aero standards, it goes to some other folder for me. I thought I have missed the schedule. So
Oh
I'm
my
like,
God.
okay, let's kick off. I waited for 2 minutes. 24 members became 28 or 30. I'm like, okay, it's actually starting at 6:15.
Oh my gosh.
Then I was trying to reach Hassan. He couldn't respond. Then I started. Then Hassan messages me saying, no, the session is actually at 6:50 only. Then, we actually had to request Bill Billman because he got confused with the timing. I think that 30 minutes or 45 minutes earlier he has joined and he thought the session is starting. So we had to tell Bill to wait for till Indian Standard Time 6:50. So that was funny. I think maybe he thought it is US time 6:50 a.m. I really don't know. I'm still trying to get that calculation. How did he?
No. What we did was the calendar invites 10 minutes before and 15 minutes after. That is
No,
a
Ravi,
time.
this was at 6:15 p.m. Right,
Yeah.
almost 35 minutes before. So I was like, okay. Then I realized this, the schedule hasn't changed. So that was one
No,
small
forward
confusion.
sessions is always tough. It is very, very difficult to balance until
And I
unless.
was actually listening to these sessions on, and Sripati tells me, join there, that we need to start. I'm like, okay.
Okay.
So from my side, I think, overall, I think the packet and everything came out nicely, starting from Dr. Ravi's planning 3 or 4 months back, I would say, right? So starting from there, the coordination, in the delivery, running multiple tracks, right? So I think everything came out very well. Only one, not a flag as such, but kind of like puzzle. Suppose, let's say, some audience, they want to move between the tracks, right? They're like one session in track 1 and other, one another session in track 2. Now, maybe I think in future, maybe we need to make that mechanism a bit more flexible for them move between the tracks. Now it is like they have to drop off from one, meeting and then they have to rejoin other link, right? So maybe I think that's something that we would need to consider, if we are planning to adopt this kind of mechanism for future conferences.
No, the other thing that I realized is when I joined the track 2 session at earlier, 30 minutes before, none of them were active, by the way. I'm trying to tell members that, the session will actually start late. Nobody left the session. So I realized a lot of people had joined in 2 devices in both the
Possible.
duplexes. Yeah, that
Correct.
also could be happening.
I think.
But you're right. I think switching between back and forth would be a challenge if someone wants to join one session here and the other session there.
For the UAM session, they have that Hubilo. I think that makes this all easier, so they can switch whenever they want.
Yeah.
That platform is better.
Yeah, no, Vijay showed us on Sunday, right? It was tough for us. We said forget about it because we don't know in the meantime if we go there are a lot of approvals that need to go through. Then after that, technically, there are a lot of things that need to be enabled. So this is the
Yeah, I think,
easiest.
lesson learned is, we need to think through all these points right at the beginning,
Correct.
somehow, these things we keep missing. I think this is where I think SA India technology team should, alert us. The moment we say parallel sessions, they should say this should be the solution. This is the platform we use. And we almost kind of, only last week I said, okay, how many WebEx links are going to go? So that is when, Krupal said, hey, we decided to on 2 WebEx links, etc. So that is something that,
And Ravi, just again today, after listening through the first half of the sessions, right? They were very informative. In fact, I didn't know how to be part of these committees.
Yeah.
Right. If some of my engineers want to be the part of these committees, so I think the first few sessions were really, informative, especially on. So that was very useful. Maybe if those sessions were on day one, I don't know if that would have been more beneficial. I don't know if anyone thought the same
or at least, we should ensure that, those were, yeah.
They were all
I
common
think so.
sessions, by the way. Absolutely.
Yeah,
I mean,
they were all
everybody
common
attended
sessions.
that. Yeah, they were all
Just
common
that, unfortunately, Ritesh took, too much time, and, that lady who's Kerry, her session got,
I missed it actually. I was actually looking forward to that session.
In fact, I was hoping that is an important session where, she was telling how to, be part of this thing. Anyway, lesson learned.
We can do it offline as well, Satish, if you feel okay. If we need a dedicated session, I can do a session. Okay, so we can bring the engineers. I mean, the best thing is we should bring these younger folks into the committee.
Yes. Yes.
Okay. So anyway, I think a lot of communication, a lot of this one. So Vinay and Hassan have been busy sending mails after mails, and making sure there's enough information for everybody to be on the toes.
Yeah. No,
okay.
The only problem is most of the sessions, Ravi. One more suggestion: most of the sessions when we plan, right, we should not confuse audience also in the sense. See, earlier we had the urban mobility. We could have had that conference and this conference one month gap.
Yeah.
So whatever we conduct, I think we should schedule it in such a way that is there, the enough interest is there. Otherwise, it will become like a monotonous, and interest levels also comes down. We should take care of that. That's all.
Yeah, maybe I think
that
that maybe we should request.
Yeah, we'll have to have some broad understanding of. I mean, there should be some calendar where all SAE India events are published on one calendar, so that we know what is overlapping, what is happening, next to each other. So
looks like you read my mind, Ravi. I was exactly going to say the same statement. Maybe from Aerospace Forum side, we should publish our 2022 calendar sometime soon, and then expect similar thing from other forums as well.
I mean, SAE India should maintain that common calendar where anybody decides, any forum, any section decides an event, that should be there on the calendar so that anybody can take a look at it at any point in time.
Correct.
Okay, so Hassan and team, any Vijay, Suraj, Ilango, anybody there?
Yes, sir, we are there.
Okay, Gig, first of all, thank you so much, guys. A lot of hard work. Really appreciate all your efforts, guys.
Yes.
Thank you, sir.
Lot of hard work. Thank you. Sorry for the trouble, Hassan, couple of times.
Thank you. No problem.
Okay.
I have been troubling him a lot.
So especially when I'm doing a lot of work on the communication side, back and forth.
Okay, great. So thank you so much. So let's all, gather back for our weekly call tomorrow. Yeah.
Hey, Ravi, I think we should have one here tomorrow. Just kidding.
Okay.
Okay.
Good night, sir.
Okay.
Just kidding, sorry.
Okay, good night.
All right. Good night, everyone.
Good night, everyone. Bye.
Right, bye.